So, hello, sound check, my test. Hello, sound check, my test. Hello, hello, sound check. Alright, good morning, no? Magandang umaga sa lahat. So, I apologize for the late start, no? So, nagka-problema ng konti kanina, no, with my internet connection, but it's now fixed, no? So, thank God. So, okay lang. So, we will now resume, no, with our lesson for this morning. So, we're now on week 4, no, of our refresher program. So, palapit na ng palapit, no? Yung ating board exam, no? We're inching closer. Malapit na matapos yung March. And next month, it's April, no? So, malapit na talaga yung board exam natin, no? So, let me know if yung audio ko is okay. If not, we'll fix it. And by the way, announcement ko sa Padlet, there will be no longer swapping of instructors. Kasi Sir Andres throat is not feeling well, no? So, ako muna the entire morning, siya naman the entire afternoon. So, Sir Andres needs some rest, no? Ayan. So, can you read na lang, no? The Padlet announcement, no? O yung announcement na nilagay ko sa Padlet. Okay? So, can you read na lang? Nandyan yan. And I've also gave you a handout, no? For transportation engineering. So, may topic dyan with regards to common, no? Common topics in transportation unit. Please study it na lang. We don't have time for it, no? Na discussion na in detail. May queuing din dyan, no? For that handouts. Okay? So, if you have questions with regards to these sample problems, you can chat me, no? Or my consultation tayo, pwede din, no? Ayan. Walang problema yan. Okay, so that's it, no? So we have topic natin, queuing, tapos ports and harbors. Again, these are additional topics that we need to discuss, no, for the board exam, especially particularly MSTC. So yan dalawang topic na yan, lumabas na to sa board exam, no? And possible na lalabas ulit, no? Although recently, wala na, no? Wala na, but still, we can't be so sure kasi part siya sa coverage, no? Queuing and ports and harbors. So ayan. Alright, so that will be our topic for this morning. And again, until 12 po tayo. No swapping of instructors. Yan. Okay? Sige. So again, if you have questions, padlet link lang. Okay? And let's begin, no? Let's begin our lesson for this morning, no? Alright. So simulan natin. Let's start with queuing. Yeah, no? Now, queuing, no? As defined in transportation engineering, ito yung definition niya. Now, queuing is actually not just a term in transportation engineering, but it's a common term. No? Pag sinabi natin queue, ano yung nasa isipan natin pag sinabi natin queue? Well, queue is actually described, no, as having a long line, no, or waiting service, no? Ayan, so example ng queuing. May mahabang pila ng tao nag-order sa Jollibee. Ayan, no? Basta mahaba yung pila, okay? Mahaba yung pila for a particular service, no? There's a queue, okay? Or there's a line of people waiting to be attended to. O, ayan. Yan yung queuing, no? A long line of people, or not just people, pwede din mga sasakyan, waiting to be attended to or waiting to be served to. Yan yung queuing, no? Basta may mahabang pila, no? Yan yung queue. Ayan, no? Yan yung common term, no? Queue is a common term. Sa may mahabang pila, there is a queue in that particular store. Yan, for example, a store, fast food, or whatever that is, no? That offers services. So, yan yung queuing, no? And that definition of queuing can also be applied here, no? In transportation engineering. So, sa madaling salita, pag sinabi natin there's queuing, no? In transportation engineering, meaning may mahabang pila ng sasakyan for a particular road section. So, yan yung queuing. And it needs to be studied well kasi if hindi natin ma-handle ng mabuti yung queuing natin for a particular road section, we will have this what we call, severe network congestion or we call it gridlock conditions and it's suffocating. No? Ayan. Buot kayo, no? Sa Bisaya pa, no? Medyo masikip yung road section natin if we don't deal with queue, no? We don't deal with queue properly. Ayan, no? So, queuing causes traffic. Yan talaga, no? Queuing causes traffic. And it naturally occurs, yung queuing natin, it occurs at the red lights. Yes, tama yan, no? At a particular intersection. Yan. At a particular intersection, of course, may queuing dyan. No? Kasi bicycle eh. Bicycle yung pag-pass natin ng mga vehicles, no? In a particular road section. Say, for example, the vehicle's passing here, tapos nag-stop dyan. Okay? Okay? Usually, yung path ng vehicle nito is pa ganyan, pwede din pa ganito. As soon as it stops, no, meaning stop mo na sila, of course, ano mangyayari, no? The vehicles will stop and they will fall in line, no? And they will wait for their turn para makapag-pass sila to the opposite road section. So there's a queue occurring in this particular section. So yan, at red lights or intersection. Red lights, stop signs as well, no? Same concept. Bottlenecks, ano yung bottlenecks? A bottleneck is a particular road section that looks like this, you know? So at one section, yan ang bottleneck, no? At one section, your road is wide. Then at some point in your road section, okay, sisikip na siya. Yan, there are these bottleneck sections. And obviously, at bottleneck sections, there is queuing as well. Why? Well, dito, okay pa yung flow natin. Pagdating natin dito, of course, no, obviously, yung vehicles na makakadaan dyan is konti na lang. Okay? So, one at a time, yung dapat dadaan dito. No? So, at bottleneck sections, madalas may queuing dyan. No? Yan yung ano, yan yung idea dito, no, for bottleneck sections. Or any design-based or traffic-based flow constriction. Ayan. So that's queuing. And where can it occur? Right? So yan, no? Sinimplify lang natin yung definition ng queue. But eto yung kanyang definition dito, no, sa PowerPoint. Is daw the study of traffic behavior near a certain section where demand exceeds available capacity. Now, of course, no, based on this definition, in a particular road section, meron tayong tinatawag na road capacity, no? Capacity of a road section. And that is expressed in vehicles per hour. Okay? Now, yung capacity ng road section natin is dinidesign yan, no? Dinidesign yan ng ating transportation engineer. Okay? Now, sabi dito, in transportation engineering, a queuing will occur if yung capacity nito, okay, or yung demand. Ano yung demand? That's the actual vehicles passing in this particular road section. So, paano yan dinidetermine yung demand for that particular road section? Binibilang yan manually, no? Or we use an equipment, no? Para bilangin natin kung ilan yung actual vehicles na nagpass in that particular road section, no? And it's of the same unit, vehicles per hour din yan. Okay? So, let's say ito yung demand. So, if yung demand natin will exceed our available capacity, we call this one the service rate, no? Service rate of your road section. If this one would be greater than this, then yan yung queuing. There's queuing in that particular road section. Ayan, no? So, queuing is a comparison between these two quantities, no? The service rate of your road section and the demand, or the other term for the demand is what we call the arrival rate, no? Arrival rate of vehicles in a particular road section. Ayan. Okay? So if yung arrival rate, it will exceed the service rate, there is queuing in that particular road section. Yan yung definition nito based dito. Okay? That's how we're going to explain it. Yan, no? If we're going to engineering, no? Or transportation engineering na definition. Okay? So yan yung queuing po. Alright? I hope that's clear, no? Okay. Continue tayo. Okay, now, to compute the traffic intensity, of a particular road section, ito yung formula. Okay? I, that's equal to QA over QS. Okay? Now, ano itong QA? Ano ba itong QS? So, ito yan, no? Where QA, that's the arrival rate. Ito yung demand, no? Ito yung demand, no? So, yan yung arrival rate. That's the actual number of vehicles passing to a particular road section in a given time. So, kaya naka-vehicles per hour yung ating unit. Right? Then, ano yung QS? Yan yung ating service rate of that particular road section, and that is the available capacity of that particular road section, also expressed in vehicles per hour. Ayan. Okay? And based sa value ng ating traffic intensity, we can describe the nature of our queue. Yan, that's the idea there, no? Now, the first nature of queue is we call the oversaturated queue. Ito, severe condition na ito ng queuing, no? This will produce gridlock conditions or network conditions na if you have an oversaturated queue. And that will occur if the arrival rate will be greater than the service rate. Ayan, obvious naman, no? O, dinesign mo, ganyan yung capacity. And mag-exceed yung actual oversaturated na yan, no? Okay, that's it, no? Then you have undersaturated queue. Well, undersaturated queue, sa madaling salita, that is if the demand is less than the capacity. Okay? Or does not exceed. Ayan. yung demand or yung arrival rate is less than the service rate of that particular row section. So that's the under-saturated queue. Okay? Then, the saturated queue naman, no, hindi over, hindi under, okay, that is when your arrival rate is just equal to the service rate. Yung pinaka-ideal dito is this one, of course, no, under-saturated queue. Yan. Okay, okay din to. However, if maganito na, yung danger, of course, maging oversaturated siya. Okay? So, these are the natures of your queue, no? Depende sa ating comparison pala. Comparison between the arrival rate and the service rate. Okay? Ayan. Okay. Sige, by the way, no, for the traffic intensity, no, for the traffic intensity, the larger the value, it describes how the intensity of traffic, meaning grabe yung traffic dyan, no? Kasi mas malaki yung arrival rate mo compared sa service rate. If maliit yung value ng ating traffic intensity, of course, parang almost free-flowing siya, kumbaga, no? Ayan. If forever mas maliit, no? Mas maliit yung value ng arrival rate natin compared sa service rate. So, yan traffic intensity. Describes the nature of traffic at a particular section, no? Based sa ratio ng arrival rate and ang ating service rate. Okay. So here are the formulas that we need to consider. You have here the Little's formula. Okay. So the Little's formula talks about the average queue size, no? Queue size pala, sorry, no? The average queue size, now which is typically measured in number of vehicles po yan, yung queue size natin. Okay? That is equal to the arrival rate. That's vehicles per unit time. Okay? So the vehicles per unit time, that could be vehicles per second, vehicles per minute, vehicles per hour. Okay? Basta vehicles per unit time. Then multiplied by the average waiting time. So ano itong average waiting time? It makes up both the delay time, okay, plus the service time. Now, ano itong delay time? Of course, yan yung time na, ano, well, it's actually similar to this, no? Pag sinabi mong waiting time, no? So that's the time where the particular vehicle, no, particular vehicle is supposed to be, served, no? Pero na-delay siya, no? Because due to some circumstances. So, yan yung delay time, no? Delay time plus service time. Okay? Or you can just say, waiting time for a particular vehicle. Yan. Okay? Waiting time. Kasi pag may queue ka, of course, nakapila yan, no? Nakapila yan. Yan. For example, nasa toll booth tayo. Yan. Okay? So, of course, if you are to consider this vehicle here, okay, of course, may delay time siya. Kasi may mga vehicles pa before that vehicle na nakapila. So, the time it takes for this vehicle to be served by the toll booth, ayan. So, that would be the delay time. Ayan. Okay? That would be the delay time. And once yung vehicle na to is nakarating na sa toll booth, okay? Nakarating na siya sa toll booth natin, okay, 'di ba? Of course, sa toll booth, i-issuean ka pa ng ticket, 'yun, magbabayad ka pa, ganun. So, diyan nag-o-occur yung ating service time. Yan. Okay? And the total sum of this is the average waiting time. Ayan. Okay? So, yung formula nito is eto. It's the times the average waiting time. Ayan. Okay. Sige. Then you have here the average waiting time, which excludes the service time. Wait lang ha. Okay. Wait lang class. Okay. By the way, for all of you watching here, okay, nag-remind si Sir on this sa akin. Later this afternoon, your topic will be depreciation. Okay? Depreciation yung topic nyo po under economics. Okay? Ayan. This morning, queuing and ports and harbors. Okay? We can actually finish it siguro, no? Kasi tuloy-tuloy tayo. This afternoon, for your miscellaneous one, yun, under Sir Onde, that would be depreciation. Okay? Okay, where were we? Okay, average waiting time, no? Excluding the service time. Okay, ito yung formula natin. So, remember this one lang. Then you have here the average total delay, or that's the average waiting time. That's the other term. Okay? Average total delay. So, synonymous lang pag sinabi nating total delay and waiting time, actually. Okay? So, average total delay, that now includes the service time. So, that's this one plus this one. Ito yung ating formula. Okay? Ayan, no? So, if we are to compute the average waiting time, computein muna natin to, then times natin sa arrival rate ng vehicles. Kuha na natin yung length of queue or the average queue size. Yan. So, please, no, remember these formulas lang. Yan. So, sometimes, no, sometimes sa board exam, given to, hint, no, kumbaga, so kayo na lang bahala mag-interpret, sometimes hindi, no? So, just please, no, remember these formulas lang. Okay, then sample tayo, light examples lang, no? So, let's have this one. So, vehicles arrive at the entrance of San Juanico Bridge in Tacloban at a rate of 180 vehicles per hour. So, vehicles daw must stop at the toll gate where vehicles will pay a toll fee upon entering the bridge. Now, it would take 15 seconds per vehicle for the attendant to issue a trip ticket. Okay. Compute the traffic intensity at the bridge. So, ano yung traffic intensity ulit? The traffic intensity, that's the ratio between the arrival rate over the service rate. Let's identify kung ano yung mga given natin for the arrival rate and the service rate. Okay? For the arrival rate naman, okay, given siya, no? Keyword, vehicles arrive at the entrance, no? Vehicles arrive at the entrance of San Juanico Bridge at this rate, 180 vehicles per hour. Automatic, that's your QA. Now, ano yung service rate natin? Eto, nandito, it would take 15 seconds per vehicle for the attendant to issue a trip ticket. Of course, nag-i-issue ka ng trip ticket, no? So you are what's that term here? You are in service. I think that's the right term. So may service na nangyayari dyan, no? I'm out of words. Basta, in this statement, okay, obvious naman, no, that there's a service occurring, no, in this statement. So, yung toll booth attendant, nag-issue siya ng ticket, no? And the toll booth attendant can complete the service in 15 seconds per one vehicle. So, yan yung QS natin. Yan. Okay? So that's one vehicle per 15 second. Yan yung QS natin. However, para uniform yung units natin, we should convert this one to vehicle per hour. Okay? Vehicle per hour. Pwede mo naman tong gawing vehicle per second din. Kaso lang, no? Per 15 second, no? So, dapat vehicle per hour. No? Yan yung gagawin natin. So, by converting this one, we simply convert the seconds to hours. Yan. Okay? Convert lang natin yan. And this will be your service rate. Okay? So, the traffic intensity, that's QA over QS. So, ratio lang natin. And that answer would be 0.71. That's letter B. Yan lang. So, formula based for this problem. So, remember the formula lang. Okay? Alright, next. Let's have this one. Okay, an off-ramp traffic must stop at a single toll booth, okay, at the entrance of a highway. So, the arrival rate at the toll booth is 80 vehicles per hour. If the service rate is 86 vehicles per hour, determine the number of vehicles waiting to be served. Now, eto, wala to dito, no? Number of vehicles waiting to be served. Wala dito, wala dito na formula. Okay? Hindi ko pinakita dito. But it's actually in your handouts, no? And formula-based lang din po ito. Okay? So, identify muna natin yung given. So, arrival rate is 80 vehicles per hour. Service rate natin is 86 vehicles per hour. Now, if eto yung pinapahanap, determine the number of vehicles waiting to be served. Ayan. Ito lang yung formula na gagamitin natin. Okay? So, remember this one. Sometimes, again, given siya as a hint for the problem. Okay? Sometimes hindi. No? So, para safe na lang, please remember, pag sinabing determine the number of vehicles waiting to be served, ito yung formula natin. Right? Then, direct substitution lang. And eto siya. 12.4 and you always round up po. Hindi ka magra-round down. Ha? That's the rule. Okay? You always round up. Okay? So, 12.4, that's 13 vehicles. So, that would be letter Okay, then, next tayo. So, direct sub naman no? Let's have this one. Vehicles arrive at the entrance booth of MGM Hotel in Las Vegas to see the boxing match of Manny Pacquiao at the rate of 4 vehicles per minute. So it took the attendant 30 seconds to process the parking tickets. Determine the rate in which the vehicles move after getting their tickets in vehicles per minute. Okay. So, identify natin yung given. You have here the arrival rate. Yan, given. Keyword, arrive. The vehicles daw arrive at the entrance of the booth of the MGM Grand Hotel in Las Vegas. And that rate is 4 vehicles per minute. Now, etong 30 seconds, okay, that's the total delay. No? That's the total delay. Kasi sabi sa problem, it took the attendant 30 seconds to process the entire parking tickets. So, that's the total delay. Okay? So, if we base it sa formula, okay, T sub D, eto yan, no? That includes service time na. So, yung 30 seconds na yon, that includes the delay time in each vehicles, no, waiting to be served, plus the service time. Yan. So, that's the total delay na. Okay, basis statement. Okay? Then, ano yung pinapahanap? The rate in which the vehicles move after getting their tickets in vehicles per minute. QS yan. Okay? Service rate yung pinapahanap dyan. Okay? Ayan. So, okay, yung gagawin na natin, yung 30 seconds, okay, convert natin to minute. And of course, that's half a minute or 0.5 minutes. Okay? So, using the formula for the total delay, that's 1 over QS minus QA. Yan. Then, solving for QS, the service rate at the entrance booth of MGM Hotel is just equal to 6 vehicles per minute. So, that would be letter D. Yan. So, formula based lang, no? Formula based. Okay, then next. Okay, formula-based lang to lahat, no? Ayan. So the number of vehicles that can enter the on-ramp of Subic Clark Expressway is controlled by a metering system. So if the vehicles can enter the expressway at a rate of 500 vehicles per hour, and the rate of arrival, okay, of the vehicles of the on-ramp is 400 vehicles per hour during the peak hour, determine the expected number of units waiting to be served in the system. Okay. So, ito yan, no? So, the arrival rate, okay, that's your keyword, no? Rate of arrival of the vehicles on the on-ramp, that's 400 vehicles per hour. Ito naman yung service rate natin, okay? That's the design capacity of your particular road section. Yan, no? So, QS, that's 500 vehicles per hour. So, ano yung pinapahanap? Expected number of units waiting to be served, okay? Now, ito yung formula na gagamitin. Yan. Okay? I think we had this one a while ago, no? Ito. No? Number of vehicles waiting to be served. Yan. Or sometimes, yung term yan, expected number of units waiting to be served. Yan. So, if yan yung term, number of vehicles waiting to be served or expected number of units waiting to be served, ito yung formula na gagamitin natin. Okay? Again, it's in your handout, so kindly check na lang. Alright? So, direct sub lang. Yan. And the number of vehicles is 3.2. Again, always po tayo round up. So, that will be 4 vehicles. Letter B. Yan. Okay, now, to be honest lang, no, to be honest lang, queuing is actually a very broad topic, no? So, here lang, I'm only showing you some problems na formula-based. Okay? Yan. So, it's a very broad topic and it's really hard to choose, no, which one should we focus on. But, after this, no, yung mga formula-based, kasi sometimes, yung lalabas sa board exam, this particular problem, then magbibigay ng hint sa examiner. So, at least man lang, if may lalabas na isa dito, at least naman, if ibibigay yung formula, at least you know how to use it. Okay? You know how to interpret it. Ayan. But that's not the highlight of our discussion, no, for this morning. Okay? Yung highlight natin is yung similar sa lumabas sa board exam. Okay? Yun yung mga highlight natin na topics for this morning. Okay. Do you have any questions so far? Wala. Tahimik naman, no? Okay. By the way, visible lang ba yung time ninyo at your end? Yung time natin, is it visible? Or pwede ko siyang i-change ng location. Is it visible in your end, yung time natin? The time and the date? Okay lang kayo sa posisyon ng time? Pwede ko siya ilipat sa top, no, if you want. Okay lang. Okay, okay. Anong yes? Ilipat ko? Okay lang. Okay lang. Okay, okay. Okay lang. Alright, sige, thank you. Good morning, sir. Good morning, sir. What will be, sir, on this topic for tonight, sir? Yun, na-announce ko na, depreciation po. Yan, no? Depreciation under economics, no? Now, class, if ever, no, if ever meron pa tayong miscellaneous topic next week, ito, announce ko na lang, we will have spiral curves. Okay? We will have spiral curves next meeting if ever may miscellaneous pa tayo. Okay? And I think that will be the last miscellaneous topic siguro for MSTC. Okay? So next week, if may miscellaneous pa tayo, we will have spiral curves. Okay? Yeah. So, sige lang, no? Wala tayong choice. I know, no, na ano na kayo, na-overwhelmed na kayo, no, sa mga topics, no, and your preparation. But sige lang, no? Laban lang, no? Wala tayong choice, no? Wala tayong choice. Okay? Alright, sige, let's continue. Let's have this one. Okay, now, eto na yung mga highlight problems natin. Dito formula-based. Some of them, we need to really graph them. Okay? And some of them, iba naman yung approach natin. Okay? Now, the Northern Luzon Expressway, or NLEX, which we're very familiar with, is designed to have a roadway capacity of 120 vehicles per minute. But due to resurfacing of the portion of the expressway, the road capacity was reduced to 60 vehicles per minute. So the traffic arrivals are 80 vehicles per minute. The traffic then resumes 30 minutes after. May after pa yan. Sorry, no? After. Yan. So we have to compute the maximum queue in vehicles. Yan. Compute the maximum length of queue if the average length of one car is 4.5 minutes. And how many minutes will the queue dissipate? Okay, by the way, may isa pa pala. Determine the total delay in vehicle per minute. Okay. So, ito yan, no? Now, we have no choice but we need to graph, no? We need to graph the arrival rate, no? The arrival rate of our vehicles. Okay, ano yung purpose ng pag-graph natin? Para makita natin yung queue. Saan dyan yung, may pasas natin yung queue natin. Okay? Alright. The arrival rate per unit time, graph natin yan. And we also need to graph the service rate or the departure rate, no? Yan yung other term for service rate. Departure rate per unit time. Okay? Departure per unit time. We need to graph it and wag kayong mag-alala kasi yung graph nito linear lang. Bakit siya linear? Kasi, di ba, for the arrival rate, 80 vehicles per minute yan. Meaning constant yung rate natin. Meaning yan yung slope natin if you are to graph it per unit time. No? 80 yung slope natin, no? 80. Okay, say for example, no? Say for example, ito yung axis natin. On the vertical axis, dito natin ipa-plot yung volume, no? Or that's the number of vehicles, no? Passing towards a road section. At the horizontal axis naman, dyan natin ipa-plot yung time, no? Yan. Now, unahin natin yung arrival rate. Again, linear lang yung graph niyan. Okay, linear lang. And it just passes through the origin. Yan. Okay? Just passes to the origin. Kasi yung magiging equation ng line na yan, no? Magiging equation ng line na yan is just slope is 80 per 1. The equation will just be 80 times t. Di ba? Usually, if may equation tayo of a line, y equals mx plus b, kumbaga, the y-intercept for this line is 0. No? So, of course, this line will just simply pass to the origin. Ayan, no? Mag-pass lang yan to the origin. Kasi, 80 times t lang yan, no? O, laos-laos na siya. Okay? So, linear yung graph niyan, no? For both the arrival and the service rate. Okay? Now, dito tayo sa service rate. Again, malalaman nyo if service rate yan if you have a term na capacity, roadway capacity. Okay? Meaning based on design yan, no? Design parameters. So, you have your roadway capacity daw, 120 vehicles per minute. Originally yan, no? Originally, 120 vehicles per minute daw. But sabi sa problem, meron ka daw resurfacing at the portion of the expressway. So, yung ginawa dito, the road capacity initially nireduce muna natin to 60 vehicles per minute. Meaning, if we are to graph that one, okay, from the origin, since 60 vehicles per minute yan, okay, yan o, ito yung 30-minute mark, yan. So, yan yung graph na yan for the service rate, no, or departure rate. So, from 0 to 30 minutes, ayan, okay, so ito yung arrival rate natin, okay, which is, not arrival, service rate or departure rate, which is 60 vehicles per minute. And yung graph niya or equation niya in terms of time, that is 60 times t. Okay? 60 is the slope, no? This is your x value, yung t. Wala kang y-intercept. It still passes through the origin. Okay, ayan. Now, sir, bakit from 0 to 30? Paano nalaman na from 0 to 30, 60 vehicles per minute yung ating departure or service rate? Okay, because of this term. The traffic then resumes after 30 minutes. Meaning, for the first 30 minutes, yan, for the first 30 minutes po ng ating time, duration, the roadway capacity was 60 vehicles per minute. Initially. Okay? Now, yung ibig sabihin ng statement nito na the traffic then resumes 30 minutes after is that after 30 minutes, bumalik na yung capacity natin to 120 vehicles per minute. Yan yung ibig sabihin yan. Meaning, from this portion, yan, from this portion to here, for the rest of the portion, okay, eto na yung ating service rate, 120 vehicles per minute. And yung line natin pa ganyan. Now, sir, bakit pa ganyan yung line natin? Because after such time, okay, after such time, yung queue natin will dissipate or will disappear. Meaning, wala nang queuing. Okay? Meaning, your departure and arrival rate at some point will intersect. So, if mag-intersect yung graph ng dalawa, meaning wala ka ng queue. Okay? Pero hindi natin alam at what time. But we know at some point, the queue will dissipate. So, ayan. So, from this portion, after the 30-minute mark, yan, towards, ayan, no, that portion, bumalik na yung roadway capacity natin to 120 vehicles per minute. Okay? But here's the thing. Look at this line. Now, ano kaya yung magiging equation nito? Well, look, if you look at this line, it does not pass through the origin. Okay? So, wala na siyang, hindi na zero, no? If our standard equation is y is equal to mx plus b, yan, meron na tayong y-intercept b. Yung m natin, of course, that's the constant value, no? Which is the slope, 120. Yan. 120, x, of course, is t. Ano yung magiging b natin? The y-intercept. Yung b natin is this value. Yan. So, ilan yan? Diba? That is 60 times 30. Diba? Okay. Yan. The value of this is 60 times 30. Okay? Or that's 60, then time. No, time is 30. 30 minutes. Okay? Meaning at t30, yan, at t equal to 30 minutes, at this point, at t equal to 30 minutes, ilan yung volume natin? That's the y-intercept for this line. Ayan, no? So, at t equal 30 minutes, okay? So, ano yung equation na ulit natin from this point to this point? The equation is 60 times t. So, kuha natin yung y value at this point, no? Or the volume at that point. And that is 60 times 30, so that will be 1,800. And that 1,800 will be the y-intercept of this line kasi wala na siya sa origin. So, instead of 120t, yung equation for this line, magiging ganito na siya. That's 120t, ayan, plus 1,800. Okay? Or not 1,000, not 120 times t pala, sorry. Hindi na siya 120 times t. Why? Okay, that's t minus 30 na, no? Kasi, okay, at this portion to this portion, yan yung t natin. Okay? But of course, 30 minutes na yung nag-elapse dito, 30 minutes na. So, yung remaining time, yan, for the 120 vehicles per minute na capacity, that is just T minus 30. T minus 30 na yan. Okay? So, ito yung X, no? 120X, then ito yung Y-intercept, 1,800. So, iba na yung equation for this line. Okay? Ayan. So, that's the explanation right there. So, for this, that's 120 times T minus 30. Ayan. Y-intercept is 1,800. Ayan. So, yan yung graph natin. Okay? Yan yung graph natin. Okay? And again, the arrival rate, no? The arrival rate, yung graph niya, that will always be above the departure. Okay? Ayan. Okay. Now, part 1, ano daw yung maximum Q? Now, to calculate the Q, okay, before we compute the maximum Q, eto lang yan. Q is the arrival rate, yan, minus the departure. Okay, that's how we're going to calculate the Q. Now, yung tanong daw is maximum Q. So, if you look at the line, yan, look at the graph, okay, hanapin mo lang dyan kung saan dyan yung pinakamalaking difference between the arrival and the departure. Okay? Yung pinakamalaking difference. And if you look at the graph, walang iba. Ito yan. Ito yung pinakamalaking difference between the arrival and the departure. Diba? At time equal to 30 minutes. Look at the difference between these 2 points compared to the other pairs. Let's say if you choose this pair and this pair, ayan, choose that one. Di ba? Maliit compared to this. Okay? Dito naman, tapos dito, if you choose these points, ito yung arrival, ito yung departure at a certain time, di ba? Mas maliit, no? Compared to this. So, based lang on the eye test, ito yung maximum Q natin. Okay? Yan. So, that's the maximum Q. So, that's arrival, which is 80 times T, minus the departure rate, 60 times T pa yan, no? At this point, no? Yung equation yan is 60 times T pa yan at that point. As long as lalagpas na tayo dyan, no? So, your equation will now be this. Pero hindi, we're exactly at this point, no? So, 60 times T pa yung departure natin. Okay? And of course, T natin, that is 30 minutes. Okay? Kasi yung Q natin, yung units niyan is in vehicles. Okay? So, substitute natin yung time, 30 minutes. Okay? Yan. Right? So, the maximum Q is 600 vehicles. That would be letter A. Yan. Alright? Then, number 2, we are to calculate the maximum length of Q if the average length of one car is 4.5 meters. So, eto in terms of meters na, yung ating length of Q. So, we're just simply gonna compute this one, etong vehicles, into meters. Okay? So, yan yung maximum Q length natin, about 600 vehicles. Then, sabi sa problem, that one car, okay, or one vehicle is 4.5 meters. Ayan. So, yan yung conversion factor natin, no? For one vehicle, that's equivalent to 4.5 meters in length. So, using that conversion, okay, the maximum Q in terms of meters is 2,700. So, that would be letter D. Ayan. Okay? Then, number 3, how many minutes will the Q dissipate? Anong ibig sabihin yan? Meaning, yung mag-intersect yung ating arrival rate and departure rate. And at that point, your Q is 0. Yan. Meaning, yung difference ni arrival and departure, that would be 0. Okay? That's for part 3. So, this, no, at this portion, at that time. Yan. So, from 0 to this. So, ilan yan? Okay? So, for part 3, the Q, again, the concept is that's arrival minus departure. Okay? So, again, if mag-dissipate yung Q, okay, your Q is 0. That is equal to the arrival rate. Ito yung equation niya. That's 80 times T. Minus, okay, ito naman yung departure rate natin this time. Okay, use this equation. Okay? Kasi at this line, at this point, iba na yung equation ng line natin. So, ito na yung magiging gagamitin na equation for the departure rate. So, in this equation, simply solve for T lang, no? Solve for T. Shift solve lang, and you will have T equal to 45 minutes. Okay? So, that would be letter D. And lastly, total delay in vehicle minute. Now, the total delay is simply the area bounded. Yan, the area bounded between the arrival rate and the departure rate. So, yan, that's the area right there. And we can just simply divide this one into triangles. Okay? So, total delay natin for part 4, okay, that using this triangle, okay, base natin is, Okay, 1/2 times 600. Height natin is 30. Okay? Yan. Then plus, eto, this one. Okay? That's 1/2 600. Okay? Then height is time 45 minus 30. Okay? So evaluating that one, eto yung total delay natin in vehicle per. Alright? So that's it. That's letter B. Ay, wait lang ha. Wait lang. Ay, sorry. Okay. Yung 600 dito, that's the height here. Yan, sorry. Ito yung 600. Sorry, sorry. Ito yung 600. Okay. I apologize, no? I apologize. Okay? I apologize. Ito yung 600. Then yung height natin, that's the time. Okay, that's the time. So yan yung 30 minutes. Okay? 30 minutes. Ito. The time is yung base. Yan. So yan yung 30 minutes. Sorry, sorry, sorry. No, for this triangle. I apologize. So yung height niyan, that's the 600. O, di ba? Ito, na-compute na natin yan. That's the maximum Q. Okay? O, yan yung 600. Okay? Then yung 30, yan yung base from 0 to here. So yan yung 30 minutes. Okay? Then for this triangle naman, eto, okay, same height lang. That's 600, no? The maximum Q. Okay? Yung base naman niya, eto yan. That's T minus 30. Okay? Apologize, no? So yan. So that's 13,500 vehicle unit. That's number 4. Tanong ko lang po, ano po ibig sabihin ng resurfacing? Resurfacing, it could mean different things siguro, no? Resurfacing, wait lang ha. Confirm lang natin yan, no? So it's a maintenance, no? Maintenance yung resurfacing, no? Mag-add ka ng another asphalt layer over an existing surface, no? To extend the life of your road. So yan yung resurfacing, no? So you will add another, you will say for example, you will add an asphalt layer to an existing layer. Okay? Sir, paano ma-differentiate ang service rate at departure rate? Service rate and departure rate are actually synonymous, no? Synonymous lang siya, no? That's the other term. Departure rate tapos service rate. They are synonymous. Sir, may mga equation naman tayo sa mga lens. Pwede lang siguro to i-integrate. Pwede naman, no? Kayong bahala. Pwede nyo i-integrate, no? Pwede nyo i-integrate. Walang problema yan, no? But here, okay, mas madali naman if we're going to use triangles lang. For part 3, triangles lang ba? Look at this, no? Yan, area man, area of this. Di ba ito yung triangle natin? This one. Okay? Ito yung area natin. That's the first triangle. Yan, no? Yan yung triangle natin. Oh, it represents this area. Height niyan, ito yung height nito, which is the maximum Q. That's 600 vehicles. Ayan, ito, nakuha na natin yan. Di ba? Ito yung height, look at this. Maximum Q. Yan yung height natin. Nakuha na natin yan. Ay, part 3 pala, sorry. Part 3, hindi pala part 4. So, part 3, okay. How many minutes will the Q dissipate? Ayan, no? Yan, from 0 to T. At that point, ano ibig sabihin ng dissipate? Meaning, mawawala na yung Q natin. Okay? Your Q dyan is 0. Ayan, no? Wala ka ng Q dyan kasi wala ng height difference between the arrival and departure. Okay? Wala na. Okay? So wala ka ng difference between the arrival and departure at that point. So ilang time daw from 0 up to that point na mag-0 yung queue natin. Okay? And alam natin, to calculate the queue generally, that's arrival minus departure. Ayan. And look at this point, di ba? So at that point, yung arrival natin, okay, ito pa yung equation ng line natin, 80 times t. Di ba? At that point. However, yung departure natin, okay, di ba at that point, ito yung line. No? Ito yung line. So yung equation na gagamitin natin for that line is this one, not the 60 times t. Kasi yung 60 times t natin is only from 0 up to here. Ayan. So from here up to here, your equation for the departure is eto na lang. Okay? Yan. So, yan. That's your equation now, working equation to calculate the time, no? The time that the Q will dissipate from 0 up to that point. Yan. So that's 80t, yan yung arrival rate natin, minus the departure rate. Ito yung equation natin at that point. Then shift solve na lang, okay, that's 45 minutes. Okay? So yan. Kung sinabing dissipate, locate lang the point kung saan wala nang difference yung arrival and departure. Okay? Yan. Okay, now the explanation for road capacity, okay? Road capacity, ito kasi yan, kung bakit service and departure is used synonymously. Kasi pag sinabi mong service rate, okay, it includes the total time, no? That the vehicles are arriving at the same time, no? They pass through that certain road section. Meaning, napagservisyohan mo na yung mga vehicles. Pag sinabi mong arrival rate, okay, kakaano lang nila, no? Kaka-arrive lang nila, no? They are approaching that particular road section. Okay? Now, service rate, okay, meaning, okay, tapos na, napagservisyohan mo na yung mga vehicles. Meaning, for example, ay toll booth. Okay, toll booth, na-issuehan mo na ng ticket. Okay? Na-issuehan mo ng ticket, nakababayad na. Tapos, after that, okay, they pass, no? They now pass to that particular road section. Meaning, they have departed after that. So yung departure rate and service rate are just used synonymously. Okay? Kasi sa departure, ayan, departure meaning they are leaving that particular road section. Meaning, tapos na silang mapagservisyohan. That's why the service and departure rate are just used synonymously. That's the explanation. Okay? Nakuha ba? So ayan, no? You have keywords naman for the arrival rate. No? Ito, traffic arrives. O, ayan. That's your keyword. Okay? Yan. So, capacity, okay, capacity naman, yan yung service or departure rate. Dinidesign yan eh. Dinidesign. Dinidesign yan. Kaya yung departure rate or service rate, yan yung estimate ng transportation engineer na, okay, at this particular road section, okay, after the service, okay, ito yung number of vehicles, no, na mapag-servisyohan niya after that particular time. Okay? So, that's why yung capacity is, another term is service rate, another term is departure rate. For the arrival rate, di kayo malilito. Kasi may keyword, arrival. O, yan. Yan yung keyword. Okay? So, tandaan natin na departure, okay? Yung departure, capacity, service rate, they are used synonymously. Okay? Okay. Again, resurfacing, okay, maintenance yan. Okay? Road maintenance yan. Wait lang, class, no? Wait lang. Whew. Ah. Ah. Lang. Ginawa mo na ako, ah. Sige lang. Let me take a breather muna ha, sandali. Okay? Medyo naano na din kami, no? Sa refresher. Lalo na yung math class, to be honest lang, no? Grabe talaga yung research namin sa problems, no? Hirap habulin ni Sir Dakay. Okay? So, yan, no? Okay na. Sige. Next tayo. Ha? Okay, paano naman if eto yung problem? Now, eto yung pinaka-common sa board exam. Take note of this, no? Pagdating sa queuing, okay, eto yung pinaka-common class. Okay? Most common problem for queuing. Okay? So, I would suggest, pwede nyo itong pagfokusan. Okay? Yan. So, ito yung kadalasan lumalabas, no, sa board exam. So, ano yung approach natin? If ever ganito, ano yung approach natin? Okay? So, morning peak traffic upstream of a toll booth is given below. So, the toll plaza consists of 3 booths, no? Each of which can handle an average of 1 vehicle per 6 seconds. So, ito yan, no? Bali, nag-traffic study tayo. Okay? And as you can see, from 7 to 8, yung period of observation natin. Okay? Then, the way we count the arrival rate, eto, this portion, tong cumulative volume, this represents the arrival rate of your vehicles. O, yan. Actually, this entire portion, no? That entire portion. That's the arrival rate. Now, alam naman natin, during your undergrad, or siguro, ginagawa ng LTO, when they compute the arrival rate of your vehicle, sometimes nagmano-mano pa. I don't know if nagmano-mano pa sila ngayon. Siguro may iba nagmano-mano pa, no? Then, yung iba naman, there's an equipment. No? May equipment na that can automatically calculate, no, the number of vehicles passing through a particular road section. Ayan. I remember during my college days, nag-traffic count kami. Ito yung ginawa namin. No? 12 hours pa yun. No, 6 a.m. to 6 p.m. Then for every 15 minutes yung ginagawa namin. Okay? However, hindi lang ganito yung pagka-present kasi we need to separate the motorcycles, the trucks, the passenger cars, the jeepneys, ayan, no? Ganyan yung pag-count namin. Eto siguro, ano lang, no? Generalize lang. Meaning ilang vehicles talaga napapas during the particular section. Okay? So, 7 to 7:10, ito yung number of vehicles passing. Okay, 7:10 to 7:20, ito naman siya. 7:20 to 7:30, ito naman siya. And so on. Okay? So, binibilang yan. Now, for the cumulative volume, okay, interpret lang muna natin yung table ha, kung paano to nakuha so far. So, for the cumulative volume, ganito lang yan, no? Cumulative sum. Okay? Kumaga, assume natin wala pa to. So, yung first entry mo for the cumulative volume will always be equal to the first entry here. So, 200 siya, so that's 200. Now, for the next entry, again, this is accumulated sum or cumulative sum. So, to get the next entry, that's first entry plus eto, entry nito. Diba? 200 plus 400, that is 600. Ayan. Then, for the next entry, 600 plus 500. Okay, that's it. Okay, in-explain ko lang ha kung paano nakuha yung entry dito. Okay? Then, for this next entry, ayan. Okay, diba? That's equal to this. For this, ayan. Okay, that's equal to this. And finally, here, okay, that's equal to this. Ayan. Diba? That's it. So, yan yung pagkuha sa cumulative volume. Right? Na ano yung tanong? Determine the service rate of one toll booth every 10 minutes. Determine the maximum queue. Determine the total delay. Okay? Now, for this portion, okay, dalawa yung approach natin. We'll be using the queuing diagram. Okay? We'll be using the queuing diagram. And number 2, we were gonna use a shortcut. No? Of course, queuing diagram muna tayo para mas maintindihan natin yung shortcut. By the way, itong ginawa natin sa first example, this is already your queuing diagram. Okay? Queuing diagram na po ito. Alright? Sige. Let's go back here. Now, number 1 muna. Number 1 is actually pretty easy. No? So, service rate daw. Service rate of one toll booth every 10 minutes. Okay. Now, sabi sa problem, okay, the toll plaza has 3 booths. Okay? Each booth can handle 1 vehicle per 6 seconds. So, yung service rate ng isang toll booth natin, okay, the QS, ayan, that's 1 vehicle per 6 seconds. However, we need the service rate every 10 minutes in terms of vehicles. Okay, ito muna yung gagawin natin. Yung QS natin dito, convert muna natin to vehicle per minute. Okay? Yan. So, of course, yung gagawin natin, yung 6 seconds, ayan, convert natin to minutes. Yan. Okay? Then you will have your QS, okay, in terms of vehicle per minute, 10 vehicle per minute. And remember, that's for one toll booth pa yan. O, yan naman yung hinihingi for part 1, so no worries. Now, yung tanong, service rate of one toll booth every 10 minutes. So, para ma-compute natin so that the final unit is in vehicles, multiplyan natin to ng 10 minutes. O, ayan, no? Times 10 minutes. So, multiplying it by 10, okay, the final answer should be 100 vehicles. Oh, that's letter. Okay, so ayan. Now, ito yung queuing diagram natin. Yung gagawin muna natin is we will graph, no, or we will plot the cumulative volume. Okay? So, of course, no, ito yung axis ng ating queuing diagram. Ito yung volume or number of vehicles, no, along the vertical axis passing through a particular period of time. Okay? So, at time 0, so every 10 minutes tayo, no? So, 7:10, 7:20, 7:30, 7:40, 50, and so on. No? 8 a.m. na ito. No? At 60 minutes. Okay, so first ordered pair, okay, 0, 0 pa yan. So, at 10 minutes, the volume is 200. Ayan. Okay? Ayan, no? 0, then 200. Okay? So, dito yung point na yan. Not 0. At time 10 minutes, that's 200. Okay? Then, at 20 minutes, okay, which is this one, no? From 7 to 7:20, okay, that's 600, no? So, 20 minutes, 600, dito yan. Okay? Alright. Now, next. Okay, next. You have here, okay, 7:30, 30 minutes after 7. So, yan, no? This time period. So, volume is 1,100. So, dito. Plot natin. Okay? Nag-utilize pa tayo ng queuing diagram, ha? Okay. Then, from 7 to 7:40, ayan, that period, eto yung volume, no? 1,350. So, 1,350 is somewhere here, no? Ayan. So, plot natin. Okay? Hindi lang accurate, no? Basta somewhere there, no? Then, 1,550, okay? Pagpatuloy natin, somewhere there. And lastly, 1,700, okay? At exactly 8 a.m. O, ayan. Okay? Okay. So, eto yung ating arrival date. Okay. Now, we also need to plot the service rate or the departure rate, no? At certain periods of time. Okay? At certain periods of time para ma-form natin yung queuing diagram. Okay? So, ito yung gagawin natin. We will add another column and dito natin ilalagay yung cumulative departure. Again, this cumulative departure here, this represents the service rate. Okay? Yan. By the way, letter number 1, that's letter B. Okay, so we will add another column. Okay, fill in natin yung data for the cumulative departure at each period of time. Yan, compute natin. Now, yung first entry sa cumulative departure, for this example, that's equal to the first entry of the cumulative volume. No? So that is to. By the way, the total service rate for the entire system, if tatlong booth, okay, take note lang, kasi yung 100 vehicles per one toll booth pa yan. Okay? So, for the entire 3 booths, okay, so yung service rate nila in terms of vehicles, times 3 lang ito. So, that's 3 times, okay, 100. So, 300 vehicles for the entire system. Okay? Yan. So, move to the next slide tayo. Okay? So, total service rate, okay, ayan, no? That's 300, no? Or 30 vehicles per minute. Now, if we're going to divide it per 10 minutes. Okay? Anyway, dito tayo. Now, the principle here for the entry, dapat yung service rate natin entry should not exceed, no, the arrival rate. Okay, paano yan? Okay, ito yan, no? So, first entry natin dito, equal lang dito. So, lagay natin 200. Okay? Now, for the next entry, now, di ba service to, yung departure service rate? Yan. That's service rate. Okay. And since cumulative sum yan, di ba ano yan? That's 200 plus the next entry, then that will be the next entry. Now, for this particular example, hindi natin i-add dito. Why? Arrival to eh. You cannot add the 2 units. So, instead na 200 plus 600, ano yung i-add natin? 200 plus 300, yung entire service rate ng tatlong toll booth. Okay? Kasi sa cumulative departure, under po ito sa service rate. O, ayan ha. Under po yan sa service rate. That's the process ha. So, for the next entry, 200 plus 300. Yan. And that would be 500. Now, before mo siya i-input as an entry, compare mo muna siya sa entry mo sa cumulative departure. Okay. O, di ba? Here, for the next entry, 600 siya. O, not cumulative departure, cumulative volume pala. Now, for this entry, di ba, that's 600. Okay? Ito is 500. Okay, sabi dito, yung entry natin for the cumulative departure should not exceed for the arrival or the cumulative volume. So, kung titignan natin, 500 is less than 600. So, mas maliit si 500. So, the next entry here should be 500. Okay? So, yan. Next, for the next entry, yun pa rin. 500 plus 300. Okay? Yan yung i-add natin kasi service rate to. And that would be 800. Okay? Then, compare mo siya sa entry dito, sa cumulative volume. Again, kung sino yung mas maliit, that would be the final entry here. So, obviously, mas maliit si 800. So, 800 yung ilalagay natin. Yan. Okay, next. 800 plus 300. O, diba? That's 1,100. Compare natin dito. Obvious na. Ito yung mas maliit. Okay? So, ayan. By the way, pinaplot pala natin, no? Yan. Okay? So, from 10 minutes, okay, that's 200. Then, 20 minutes, okay, 500 yung service rate. Okay? Then, at 30 minutes, okay, ito, 800 yung service rate. Plot na natin sa queuing diagram. Okay, at 40 minutes naman, okay, that's 1,100. So, around here. Ayan, plot natin. Okay? Then, dito naman, okay, next entry, 1,100 plus 300. Okay? So, that will be 1,400. Obviously, this is smaller than this. So, that's the final entry. Plot natin dito. Okay? So, it's right here. And finally, 1,400 plus 300, that's 1,700. So, equal lang. So, okay lang, no? Kasi, ito naman yung criteria. Okay? Lesser than or equal to. So, 1,700. So, nandito yung point. And ito yung graph for ating service rate or departure rate. Ayan. Okay? Now, we are to calculate the maximum Q. So, paano i-calculate yung maximum Q? Consider these 2 points lang. Okay? Consider these 2 points. Ito, these 2 points sa arrival and departure. Sa arrival and departure, arrival and departure, arrival and departure. Kung saan dyan yung may pinakamalaking difference, that's your maximum Q. Okay? Oh, by the way, yung length of queue lang, no? Kahit wala kang queuing diagram, okay? You can actually get it by subtracting the entry, no? From the cumulative volume and cumulative departure. Kahit wala to, actually, no? Simply using the table na lang, no? So, dito pinakita ko lang, no? Pinakita ko lang. So, length of queue, from here, that's 200 minus 200, so 0. So, dito naman, that's 600 minus 500, okay? That's 100. Okay, dito naman, that's 1,100 minus 800. So, that's 300. Okay, 1,350 minus 1,100. Okay, then 1,550 minus 1,400 and 1,700 minus 1,700. Okay, so kahit wala to, masasagutan lang natin to. Okay, by simply adding these two columns. O, ayan. Okay, so una, cumulative departure, then length of queue. So, yung length of queue is entry nito minus entry nito. Okay? So, saan yung pinakamalaking difference? Obviously, that's 300. So, yung sagot dito for part 2, that's letter A. Yan. No? So, that's the maximum Q. So, 300. Okay? Now, for part 3, ano yung total delay? Okay, again, that's the area bounded. Yan, the area bounded by the graph of your arrival and the departure. And to calculate that one, we simply use the formula for trapezoidal rule. O, di ba? For trapezoidal rule, for cross-section area, anong ulit yun? That's D over 2, yan, over H1, okay, plus twice the summation of the middle heights plus the last height, H sub n. Okay? So, if you look at the area here in our queuing diagram, saan yung H1? Obviously, it's this one, 0, no? By the way, yung heights natin, that's the length of Q, ha? Yung heights natin, that's the length of Q. Okay? H1 is 0. H sub n, the last height is also 0. So, yung middle heights, eto yung mga difference natin. Oh, that's the Qs. Length of Qs. Eto yung middle heights natin. Oh, ayan. This is our middle heights. This is your H1. This is your H sub n. Okay? Ayan. Now, ano yung D ulit? D is the contour interval, no? And yung contour interval natin, nakadepende dito. So, per 10-minute cycle, meaning yung D natin, that is 10. Okay? So, substituting the formulas, H1 is 0 plus 2 times the sum of the middle heights, eto yan, then plus H of N, which is 0. Okay? So, evaluating that one, eto yung sagot in vehicle minute pa yan. Okay? Kasi of course, yung length of Q, the unit is in vehicles. Yung D natin, the unit is in minutes. Okay? So, convert lang natin to. Yung minutes to hours, no? And ito yung conversion. The final answer should be 133.33. That is letter B. Okay? So, that's it for this example. Alright, question. Actually, may lumabas na ganito sa module 3 ninyo. No? Dalawa. Dalawa pa yun. Sir, what year po yan, sir, na lumabas na problem sa board exam? I think this is, 2021. Yeah, 2021. So, nasa C reference 5. No? Yeah. Actually, no. Actually talaga, you don't need the queuing diagram. You don't need this one. Eto lang. No, sapat na. No? Kasi of course, no, well, galing sa queuing diagram, ito yung length of queue. Ganyan yung principle. No? So, pwede na. You don't need the queuing diagram. So, diretso lang. You add these two columns na lang and you will answer these questions. Okay? Ayan. So, di nyo na kailangan. But of course, for the sake of discussion, pinakita lang natin yung queuing diagram. Yan. Of course, sa board exam, no? That's a waste of time, no? Magpa-plot ka pa ng queuing diagram. So, I suggest, eto na lang, no? So, add the two columns. Okay? Sir, always po ba siya mag-zero sa end ng length of queue? Sometimes hindi. Sometimes hindi. Okay? And may example tayo niyan. Okay? May example tayo. There is a particular situation where hindi mag-zero. Okay? Good question. Mamaya may example tayo. Okay? Mamaya meron tayong example na hindi siya mag-zero. Okay? And kailan mangyayari? Okay. When we go to that example. Ay, hindi pala. Hindi ko nalagay. Sorry, hindi ko nalagay yung example. But there are times, actually, there are times. Depende yan, no? There are times. Sana naglagay ako. But sige na lang, no? There are times, there are times. But explain ko na lang mamaya, no? There are times. Kasi there are times kasi, let's say for example, at this particular time, nag-iba yung service rate. Okay? Let's say binawasan natin yung service rate. Okay? O binawasan natin. So let's say at this particular time, let's say binawasan yung service rate to 200 vehicles. Yan. So, di ba, here, di ba, for the next entry dito, so ano yung i-add natin? 1,400 plus 200. So, that's 1,600. Di ba? Oh, that's 1,600. So, of course, by principle, yung entry mo dito should not exceed the arrival. So, yung final entry mo dito, that's 1,600. So, obviously, yung end mo dito, hindi magsi-zero, 100. So, yung graph mo, sabi pa ganyan. Meron kang queue at that particular time. Depende yan. If at a particular time period, i-reduce yung service rate. So, that's the time that siguro at this time period, no, na hindi magsi-zero yung queue length natin at that time. If i-reduce yung service rate, hindi na constant yung service rate for each particular time. But as long as constant yung service rate natin for each time period, constant lang yan, mag-zero talaga to. Pero pag hindi yan constant, no, hindi yan constant, say nagbago dito, bigla na lang nagbago. Parang yung iba diyan, bigla na lang nagbago. Okay? Ayan. So, pag bigla nagbago, liliitin, okay? Liliitin yung ano. Pero paano naman sir if lalakihin? Okay, if lalakihin, mag-zero pa rin yan. But why? Kasi dapat hindi ma-exceed yung service natin to the arrival. So, you will have 1,700. So, it will only happen if yung service rate at this particular time, the last time period, is liliitan natin. Okay? So, 200. So, that will become 1,600. Ayan, no? So, liliit siya. So, yung final entry mo should be 1,600. So, yung length of queue mo dito would be 100. Ayan. So, that's the only time na hindi mag-zero yung queue natin, no? At the end. Nakuha ba? So that's the only time. There are times na hindi constant yung service rate natin. There are times, no? Depende sa problem. You need to be vigilant of that. Okay? Okay, sige, next example tayo, no? Next example. Okay. Now, let's have this one. Okay? So, during Christmas vacation, okay, ramp meters, wait lang ha. Wait lang. Okay, sakto pala. Okay. So, during Christmas vacation, ramp meters along the expressway are open during the evening peak period from 5 p.m. to 6 p.m. So, ayan, no? So, yung time period of observation natin is from 5 p.m. to 6 p.m. Then, yung pag-observe natin is per 10-minute cycle. Okay? Ayan. So, the metering system of the SC text allows vehicles per cycle to pass the signal so that, for instance, a 6-second cycle, okay, yan, 6-second cycle, meaning yung pag-pass, no, pag-pass ng vehicle, no, pag-pass ng each vehicle for that particular system is 6 seconds, no, 6 seconds, will correspond to a service rate of one vehicle every 3 seconds, or that's 1,200 vehicles per hour. So the cumulative volume and meter cycles in each 10-minute period is recorded as follows. So first, we need to determine the time when the queue is maximum. Okay? We are to determine the maximum length of queue and we are to determine the total delay. Now, we have the cumulative volume here. Okay? And look at this. We have here the meter cycle or the ramp meter cycle. And sabi sa problem that for every meter cycle na 6 second, that's equivalent to a service rate of one vehicle every 3 seconds. Ano ibig sabihin yan? Meaning, for this particular problem, okay, for this particular problem ko, mag-iiba yung service rate natin. Okay, say for example, from 5 to 5:10, ayan. So, service rate per 10 minutes, okay? So, sabi sa problem, ilan yung ano niya, cycle niya? So, cycle is 6 seconds. Ayan, no? 6 seconds. Of course, that corresponds to a service rate of 3 vehicle per second. So, ayan, 3 vehicle per second. Okay? O, yan yung service rate niya at this particular period. Na yung gagawin lang natin, of course, no, to calculate the service rate in vehicles, no, per 10 minutes for that time period, convert lang natin to vehicle per minute. Okay? Convert lang natin yan. And that's it. That's 10 minutes. Times 10 minutes pa pala. Sorry. Times 10 minutes so that makuha natin is in terms of vehicles. So, service rate yan at this time period, that's equal to 200 vehicles. Okay? Now, let's have this one. Okay. So, at 5:10 to 5:20, okay, that's one vehicle na per 6 seconds. O, bakit? Kasi 12 seconds na eh, times 2. No? So, times 2 dito. Times 2. Okay? So, times 2 na yan, no? So, 1 vehicle per 6 second. Ayan. So, convert lang natin convert natin to minutes, vehicle per minute. Then, times 10 minutes. So, yung service rate dito, that's 100 vehicles. Okay? Now, from 5:20 to 5:30, okay, that's 1 vehicle per 5 second. O, paano nangyari yan? Well, ratio and proportion lang yan. No? O, ratio and proportion. Kasi sabi dito, if the cycle is 6 seconds, o, ilan yung service rate per vehicle? 3 seconds. So, baga, the ratio is 1/2. Per meter cycle, no? Per 1 service rate, okay, time, that is twice, no? 1:2 yung ratio. Okay? So if you have a 10 meter cycle, yung service rate niya is 1 vehicle per 5 second. Kalahati yung time pagdating sa service rate. O, kita naman dito, no? That for a 6 cycle daw, 6 second cycle, o 3 seconds yung service rate. So 1/2 yung ratio natin. Okay? So 10 seconds yung cycle, the service rate should be 1 vehicle per 5 second. Convert natin to vehicle per minute, then times 10, the service rate is, okay, 120 vehicles. Then for the rest, okay, repeating naman, no, repeating. So for 5:30 to 5:40, same service rate lang dito. So that's 120 vehicles lang. Then here, okay, same lang siya ng service rate dito. Okay, so 1 vehicle per 3 seconds. Ito siya in number of vehicles, 200. And yung last time din, okay? So ito yung service rate niya, 200 vehicles. So as you can see, sa cumulative departure, ito yung cumulative departure natin. Ito na yung entry natin. Okay? So iba-iba, hindi constant yung ating service rate. Okay? So let's move to the next slide. Ayan. Yan yung service natin. Okay? Service rate pala. Service rate, no? For each. Hindi constant, no? Hindi kagaya nito, no? Na constant yung service rate natin for each 10-minute cycle, no? Na 300 vehicles. For this example, iba-iba na, no? Iba-iba na. Okay? Then, okay, lagyan natin cumulative departure. Okay, what's the principle? Yung entry natin dito should not exceed, no, the cumulative volume. So, for the first entry, cumulative volume is 150. So, 150 yung ilalagay natin. Okay? Ayan. Plot muna natin yung cumulative volume, no, for the sake of discussion. So, ayan. Ito yung arrival rate natin. So, again, ito yung principle. So, for the cumulative departure, ignore this one. Yan yung service, di ba? 200. Of course, dapat hindi yan lalagpas, no, sa ating arrival. So, dapat 150 yung first entry. Now, sir, paano naman if mas maliit to? Let's say 100 yung na-compute natin na service rate. Hindi na ito mapapareha. Okay? So, 100 yung ilalagay natin. Okay? Ayan. But dito, comparing this one to this, okay, mas maliit to. So, 150. So, there are times as well that yung first entry mo sa cumulative departure will not be the same sa cumulative volume. Depende yan sa service rate at that time period. Okay? Ayan. Now, for the next entry, ano yung principle, di ba? That's first entry dito plus the service rate at that time period. So, 150 plus 100, that's 250. Of course, compare mo yan dito, mas maliit ito. So, 250. Yan. Now, next entry, that's 250 plus 120. So, that will be 370. Yan. Compare natin dito, 420. Of course, 370 yan. Okay? Plot mo natin sa queuing diagram. Yan, 370. Okay, next entry, yan, add natin sa service rate dito, that's 390. Okay, compare natin, 560, napakalayo. So, eto, 390 yung, 490 pala, sorry. 370 plus 120, that's 490. I apologize. So, 490. Okay, mas maliit sa 560. So, yan, lagay natin. Then, 490 plus 200, that's 690. Ayan. Of course, mas maliit siya sa 720. So, 720 yung, 690 yung lalagay natin. And finally, 690 plus 200. Okay, nagkataon, nag-equal siya. 890. So, okay lang. So, mag-dissipate yung Q natin. Okay, that's it. So, ito yung graph natin for the departure or service rate. Length of Q, always yan, entry sa volume minus entry sa departure. So, dito, that's 0. Okay, dito, that's 270 minus 250. So, that's 20. 420 minus 370. So, that's 50. 560 minus 490, that's 70. Then 720 minus 690, that is 30. And finally, 890 minus 890, that is 0. So ito yung length of queue natin. Now, determine daw the time when the queue is maximum. Sige daw, if kayo yung sasagot, ito yung length of queue natin. Ano yung tamang sagot? Sige daw, sagutan niyo muna. Number 1. Ito yung length of queue natin with their corresponding time period. Ayun kaya dito yung tamang sagot. Sige daw. Kaya daw muna magsagot. Number 1. Ay, sorry. O, ito na yung length of queue. Ano yung sagot dyan? Okay? Okay, may nasagot 5:40, may nasagot 5:30. What else? How about the others? Well, obviously, no? Obviously. Okay, obviously. It's between 5:40 and 5:30. Yan lang. Kasi at that time period, 5:30 to 5:40, yung queue natin is 70 at a maximum. Pero at what time? Is it 5:30 or 5:40? Ito, wala na to. No, wala na yan. Okay? Kasi 5:10, okay, ang liit, no? Zero nga yung queue, eh. No? Yan. At 5:50, 30 yung queue natin. So, which one is it? Okay, the correct answer here is letter A, 5:40. Yan. Bakit 5:40 hindi 5:30? Now, remember class, okay, between 5:30 to 5:40, increasing pa yung number of vehicles natin, no? Look at this, di ba? From 5:20 to 5:30, ilan yung queue niya? 50. Meaning, between this time period, nag-increase yung queue natin, no? From 20 to 50. Okay? Always tayo upper limit class, no? So, pag sinabing 70, okay, yung 70 na maximum queue, di ba? It's between 5:30 to 5:40. Meaning, previously, 50 pa yan, no, at 5:30. Then, pagdating ng 5:40, dyan na siya naging 70. Increasing. Of course, no, arriving pa yung mga vehicles natin. So, you always choose the upper limit, 5:40. No? Hindi yung lower limit. Kasi pag sinabi mong 5:30, yung queue mo pa dyan is 50. Yan. No? At 5:40, yung queue mo na dyan na papasok sa 70. Ayan. That's it. Okay? Then, that's the explanation right there. Then, for part 2, maximum length of queue, okay, obvious na yan, that's 70. Then, total delay, again, that's using the trapezoidal rule, no? Area bounded by the arrival and the departure. So, trapezoidal rule, that's D over 2. D natin is the minute cycle, so 10 minutes lang. So, that's 10 over 2. Then, H1 is 0. Yan. Middle heights, eto yan. Add natin, then times 2. Then, plus the last height, which is 0. Okay? So, vehicle minutes lang yung ating unit. So, as is lang. No? Evaluating that one, this is the answer. 1,700. So, letter A, letter A, letter A lahat. Ayan. So, that's it, no? So, masterin nyo lang to, no? Pwede na to, wala. Wala na to. No? Pwede na yan, wala. Okay, tanong. Are there any questions? Okay, wala. Sige, sige. Let's have one more siguro, no? Then we'll take a break, no? Let's have one more. Okay, let's have one more. And after this example, tapos na tayo sa queuing. No, papasok na tayo ng ports and harbors. Okay? So let's have one more. Ano namang tanong, no? Okay pa kayo dyan? Okay, so let's have this one. So a newly constructed expressway, TPLEX, has a capacity of 800 vehicles per hour. Okay, 800 vehicles per hour, but per 15 minutes, ito yung capacity niya. 2,000 vehicles per 15 minutes. Or that's the service rate. Okay? Yan. In each direction under normal conditions. Take note. Now, on a particular day, which is a Sunday, an accident occurs somewhere in Pangasinan at 10:15 a.m. So pag start ng 10:15, there's an accident. Then after the accident, the capacity of the freeway in this direction is reduced to 4,000 vehicles per hour. Okay, yan na yung naging service rate or capacity niya. But, okay, in terms of per minute cycle, per 15 minutes, that's 1,000 vehicles. Until the cars involved the accident is removed at 11 a.m. So, pag tungtong ng 11 a.m., okay, na-remove na yung cars natin, no? So, meaning, pagkatapos ng 11 a.m., bumalik na sa normal service rate. Okay, we are to determine the total delay. Now, di na natin to gagamitan ng queuing diagram. Table na lang, no? Never mind the queuing diagram. Now, yung gagawin muna natin is, of course, calculate the service rate, no, for each time period. And fortunately for us, given na sa problem, no? O yan. Na, di ba, yung time of observation natin or yung cycle of observation natin is per 15 minutes yung ano natin, observation. 15 minutes. Okay? Since 15 minutes siya, look at this. Swerte tayo kasi under normal conditions daw, the service rate is 2,000 vehicles per 15 minutes. Meaning, for the time period na 10 to 10:15, ano yung service rate? Automatic na. 2,000 vehicles na yan. Kasi nagtugma eh. 15 minutes, eto per 15 minutes. So, okay na. 2,000 yan. Okay? Now, at 10:15, ano yung magiging service rate? That will be 1,000. Why? Sabi sa problem, okay, the accident occurs at exactly 10:15 a.m. Meaning, pagtugtong ng 10:15, okay, na may aksidente. And during that time period, okay, na-reduce yung capacity natin to 1,000 vehicles per 15 minutes. So, 1,000 yan. How about the next time period? 1,000 pa rin yan. Okay? Kasi magre-resume siya at 11 a.m. pa. 11 a.m. pa na-remove yung ating cars involved in the accident. So, meaning for this time period also, 1,000 pa yan. Then, after 11 a.m., which is 11 to 11:15, okay, balik na siya to normal conditions, 2,000. Ayan. And also, for the last time period, that's also 2,000. So, yan yung service rates natin. Hindi rin siya constant. Okay? Hindi rin siya constant. Okay? So, let's add another table. Okay, cumulative departure. Again, compared natin yung, eto na. Cumulative volume and service rate. Obviously, okay, ito yung principle. The entry dito should not exceed dito. So, saan yung mas maliit? Of course, yung 1,200. So, yan, ilalagay natin. Okay? The next entry, alam na natin, 1,200 plus 1,000, that's 2,200. Of course, mas maliit dito. So, 2,200. Yan. Then, 2,200 plus 1,000, that's 3,200. Okay, compared to this, okay, ito yung mag-govern. Yan. Then, 3,200 plus 1,000, that's 3,300. Okay, compared to this, ito yung mag-govern. Yan. Then, 4,200 plus 2,000. Okay, that's 6,600. Okay, compared to this, ito yung mag-govern. Yan. Okay, so 6,000. And lastly, 6,000 plus 2,000, that's 8,000. Okay, mas malaki compared dito, but this should govern, no? Kasi hindi dapat ito lalagpas. So that's 7,500. Okay, ito yung entry natin for the cumulative service or cumulative departure. Then let's add one more column for the length of queue. Again, difference lang ng cumulative volume and cumulative departure. So first entry, 0. Second entry here, that's 400. Second entry here, that's 900. Tama ba? Yeah. Third entry, that's 700. Okay. Fourth entry, that's 0. And last entry, that's also 0. Now, total delay yung pinapahanap. Okay, so simply get the area. Yan lang, no? Using trapezoidal rule. This time, yung D natin is not 10, kundi 15 minutes na. Kasi per 15 minute cycle tayo. So that's D over 2. Ayan, 15 over 2 rather. Then times H1 is 0. Ito yung middle heights natin. Yan, then times 2. No? And of course, the last height is also 0. So evaluating that one, the final answer is 30,000 vehicle per minute. Okay? Or in vehicle per hour, ito yan. So convert mo lang. Divide by 60. And that's it, no? For this example. Okay, tanong. Hey, tapos na tayo sa queuing. No? After the break, we'll have ports and harbors this time. Alright, so no questions? Sige, let's have our break muna class, no? So mag-breakfast muna kayo, no? Breakfast or snacks, no? Or have a breather muna, no? Then let's have a 30-minute break lang, no? 30-minute break. So flash ko lang to. So let's have a cool off. Okay, ayan. So balik tayo 30 minutes at 10:10 a.m. Okay? So be right back at 10 yan, a.m. Okay? So that's it. Take a break muna. Okay, I'll see you at 10:10 a.m. Okay? Enjoy your break. Mic test. Hello, sound check. Mic test. Hello. Alright, sige. Break time is over test. So, balik na tayo no, sa ating discussion po. Ayan, no? So, ayan, ports and harbors na po tayo. So, for ports and harbors po, yung pagpupokusan na po natin is about waves. As for the other aspects of ports and harbors and terminologies, of course, ibibigay ko yun sa ano ninyo, sa modules ninyo. Okay? Now, may mga ibang topics po yung ports and harbors, kaso hindi masyadong lumalabas eh, no? But sige na lang, no? We'll be focusing more on waves. Kasi ito yung, kumbaga, most frequent na lumalabas, no? Sa board exam, yung waves. Okay? Yan. So, right? Sir, morning sir, sa PRC, pwede lang ba block ang shoes? I think pwede lang. No? In fact, no? In fact, during my time, CDO ako, examination ko sa CDO, I saw someone nag-take ng exam na hindi black shoes eh. So, rubber shoes. As long as it's a closed shoes, I think that's it, no? Closed shoes lang po. But, of course, no, para di tayo ma-todats, please comply na lang as much as possible, no? As much as possible, black shoes, closed shoes, no? Yan. Okay, but okay lang talaga, no? But, for me lang, if I were you, please comply lang, no? Sa appropriate na requirement. Yan. Okay? Para hindi tayo matolats. Alright, so let's begin, no? And I think hindi lang tayo abot ng 12 siguro for this morning, no? Ayan, no? Kasi dalawang topics lang naman. And based sa pacing natin, parang ano, okay lang naman, no? Chill lang naman yung ano natin pacing ngayon. Okay? So, konti lang din yung mga tanong, so hindi lang natin patatagalin, no? Ayan. Hindi lang tayo abot ng 12 ngayon, no? So, kung hanggang kailan lang, no? Hanggang saan lang? Depends sa testing center. Last no, may nakita po ako na may logo yung polo shirt. Ay, kaya nga, no? Depende. Depende talaga sa location. No? Depende. May iba naman na, yun, naka-jeans pa. In fact, when I took the board exam, no, sa CDU, may nakita ako, no, naka-jeans lang, tapos white polo shirt. Depende talaga yan sa testing center. Kaya nga, no, my advice, comply na lang the appropriate requirements. Di mo alam, no, kung saan ka nag-take. Siguro sa Cebu, okay lang dito, pero di ka sa Cebu nag-take. Of course, bawal yan, no? So, that's why, comply, no, the appropriate attire as much as possible. Okay? Kasi may mga ganyan, eh. Depende. Para sa Bisaya, paway bikil, no? Ayan, no? Alright, sige, let's begin, no? So, ports and harbors will be focusing on waves, no? Properties of waves. Kasi dito nakaikot lahat yung problems natin, no? For waves. So, of course, this is our ocean bottom. Yan. It's our ocean bottom right there. Then, of course, yung waves natin, no? Okay? Yung shape ng waves natin, they are assumed to be the graph of the sine function. Ito naman yung graph ng sine function natin, di ba? Okay? Yan yung sine. Kaya nga, sometimes, sinatawag natin to na sine wave. Yan, no? Sine wave. Okay? Kasi yung waves natin, okay, or yung graph ng sine natin, the graph of the sine function, it looks like a wave. No? So, yan. So, ito yung and the properties of our waves. Okay? So, yung topmost portion ng ating wave, ayan, the topmost portion of ating wave, tawag niyan ha, that's the wave crest. Okay? Wave crest, that's the topmost portion. Okay? Or you can call it the vertex of your wave, no? The topmost portion. Yan. Then of course, yung wave natin, okay, we have here a summit wave. Meron ka ding sag wave. Ito, these are your sag wave, kumbaga. No? Yan. So, ito din, that's also another wave crest right there. Okay, ito naman yung wave through. Ano yung wave through? That's the lowest point, no, of your wave. Yan, for example, if ito yung wave natin, the lowest point right there, that's the wave through. Okay? Parang sa parabola lang, 'di ba? Sa parabola, 'di ba, the topmost, that's the vertex, or the even if topmost, or even if summit or pasag yung parabola mo, of course, no, the highest point or the lowest point, that's the vertex. Yan, no? If summit curve, this is the highest point. If sag naman yung parabolic curve natin, that's the sag, di ba? Or the lowest point of your parabolic curve. Same principle lang dito. Similar pala. Similar principle. So, ito yung wave crest, the highest point, the wave through is the lowest. Ayan. Then, yung L, ano itong L? That's the distance between two consecutive wave crests. And yung L natin, okay, yung definition yan, that's the length of your wave. Or, no, not length of the wave. The appropriate term is wavelength. Yan. That's the appropriate term. Wavelength or simply the length of your wave. Yan. And mini-measure siya from one wave crest, no, to another. So, horizontal, yung distance na yan. Also, that wavelength class, okay, that wavelength is also measured between two consecutive wave throughs. Equal lang din yan. Okay? So, from one wave crest to another, that's one wavelength. From one wave through to another, that's also the same wavelength. Ayan. Okay? Alright. Now, yung height h naman, ito, that's the wave height. Ito ha. Yan. That's the wave height. Okay, that's the wave height. And that is the vertical distance between the wave crest and the wave through. Yan. Okay? O, klaro naman sa figure. Okay? Then, eto, this line here, this is what we call the still water. Okay? Meaning, level yan. No, level. Di gumagalaw yung ano natin, yung tubig o yung waves. Still water. Okay? That is our still water. Then, of course, no, eto yung depth, no? Depth of our water from the still water. Yan, yan D na yan. So, yung D na distance na yan, that's measured from the still water towards the ocean bottom. Okay? So, yan yung D natin. Right. Then, eto yung center line natin. That's the center line of our wave. Okay? And in that center line, it's also considered as the center of rotation of our wave. Okay? Ayan. And of course, in center line yan, okay, yung measurement from the wave crest towards the center line, and yung measurement from the wave through towards the center line of our wave, okay, yung dalawang yan, take h over 2, or kalahati ng h. Okay? Again na, from the wave crest towards the center line, that's kalahati ng h. Then from the center line towards the wave through, that's also kalahati ng h. Okay? Yan. Then you have here the h sub o. Yan, no? That h sub o right there, meron tong formula. Okay? Meron yung formula. That's the difference between the center line and, okay, the center line and the still water level. Yan yung h sub o. Okay? H sub o, that's the distance between the center line of your wave and the still water surface. Okay? Oh, ito yan, no? Yung mga variables natin. L, that's the wavelength. Okay? H, that's the amplitude of the wave height. Yan. That's another term for the wave height, no? Amplitude. Okay? Yan. Then, we have this what we call steepness. Okay? So, ano itong steepness? Steepness is actually the ratio between your amplitude and the wavelength. Okay? That's the steepness. D, that's the depth of still water. This is very significant, no? Yung depth ng still water natin. Kasi, yung different types of waves natin will be based on dito, depth of still water and the wavelength, yung ratio nilang dalawa. Okay? And you have your H sub O, yan, height of the center line above still water. O, yan, no? That's the, for a deep water wave. Yan. So, yan yung H sub O natin. And yung formula to get H sub O is based on ito, St. Venant and Flamand theory. And ito yung formula na yan. Okay? So, that's pi h squared over 4L hyperbolic cotangent to pi d over L. So, yan, no? These are the properties of our waves. So, kindly remember this one, okay, and understand them. So, yung mga elements ng ating waves. Right? Okay, then, let's move to the types of waves, no? Or the different types of waves natin, no? And yung or different types or classification of waves, that would depend on the ratio between, or the comparison rather, the comparison between the depth of still water and our wavelength. So, ito yan, no? So, let's say ito yung wave natin. Then, this is the wavelength, di ba? Okay, from one wave crest to another. Okay, then, ito yung depth ng still water natin. Okay? Let's say at that point, okay, at this portion, yung depth of still water natin is equal to half of the wavelength. Okay? Then, this portion from here, okay, lagpas dito, that will now be greater, no? Greater than half of the wavelength. Assumed to be greater than half of the wavelength. Now, if that would be the case, that your depth of still water is greater than or equal to half of the wavelength, that is called a deep water wave. Okay? So tandaan nyo yan, no? If the depth of still water is greater than or equal to, meaning pwede siya mag-equal to L over 2, it's classified as a deep water wave. Right? Then here's another, here's another, classification or another boundary, no? This is the first boundary where the depth is greater than or equal to L over 2. And here, this is another boundary right here. Okay? So, another boundary is when D is equal to L over 25. Okay? Now, ano naman yung boundary dito in between? Ito nakakulay green. Okay? So, that boundary right there is when the depth is less than L over 2, okay, but greater than L over 25. If that would be the case, that's a transitional water wave. Okay? So, transition from deep water wave to here, that portion right there. Okay? And if D naman, okay, is now lesser than, lesser than or equal to L over 25, it's now classified as a shallow water wave. Right? Yan, no? Now, if deep water wave yung ating wave, ito yung formula na magagamit natin, no? 2 pi v squared is equal to GL. Okay? That's for deep water waves. For transitional water waves, ito yung formula na magagamit natin. Okay? So, the only difference is, okay, look at this now. The only difference is, meron ka ng hyperbolic tangent, no? Hyperbolic tangent 2 pi d over L, no? And, kumbaga, ito lang times this. Right? So, that's for transitional water waves. Then, for shallow water waves, the working formula would be this. V squared is equal to GD. And, at the shallow water waves, sometimes it's also classified as the long waves. So, bakit long waves? Before that, okay, let's discuss these few elements muna. Okay? Now, you have this V. Ano itong V? That's the wave velocity measured in meter per second. Okay? Then G, you have here the gravitational acceleration. Of course, that's meter per second squared. Tapos, you have your T, period. Or sometimes it's called as the wave period. So, ano yung wave period? That's the time it takes for the wave to travel from one wave crest to another. Okay? Yan. So meaning, ito yung isang wave crest and the time it takes for that wave crest or for that wave to travel from this, okay, towards this wave crest, yan yung wave period T natin. Okay? Now, meron kang length dyan. So, length divided by the time, that's the velocity of your wave. Yan, no? V is just the wavelength divided by the wave period. Yan. So, yan yung period, no? Yan. Pwede din siya that your wave period is the time it takes, no, to travel from one wave through to another. Kasi same wavelength lang din naman yan. Okay? So, that's the definition of wavelength. That's the definition of the wave period. Now, bakit sa shallow water wave, long waves yung other classification? Because, okay, it talks about the wave period at that point. Yung wave period, when it comes to shallow water wave daw, by concept, according to what I've read, usually takes 30 minutes, no? 30 minutes above. So, meaning matagal yung wave period. That's why it's also called a long wave, no? At shallow water waves. Diyan mag-occur yung long waves natin. Long waves having longer wave period. Yan yung ibig sabihin, no? It describes the periods. Meaning, at the shallow water waves, the wave period is longer. 30 minutes above. Yan, no? By concept. Alright? So, that's it, no? These are the working formulas that we need to consider. Alright? Okay, then, the next question should be this, no? Sir, how do we know which formula to apply? Okay, good question. So, example tayo. So, you have here, a tropical typhoon Yolanda hits the country which causes a storm surge in Tacloban City. So, the wave period at a point having a depth of 36 meters in the ocean is 6.4 seconds. So, we have to compute the height of the wave if it has a steepness of 0.14. So, let's identify the given muna. Okay? So, solution, okay, ito yung depth of still water natin, no? Nakastate sa problem. So, yung wave period daw at a point having a depth of 36 meters. So, pag sinabing ganyan yung statement, automatic, that's the depth at still water. Okay? Then you have the wave period, which is 6.4 seconds. Okay? Now, steepness is 0.14, and alam natin, that's the ratio between the wave height over the wavelength. So, We need the wave height, but we also need the wavelength. Now, as for the wavelength, okay, we need it in comparison to the depth of still water. So we need to identify if etong particular problem, is it deep water wave, transitional water wave, or shallow water wave, or long wave for that matter. Okay? Now, hindi naka-state sa problem, no, na it's a deep water wave ba siya, transitional ba siya, or shallow. So, if hindi naka-state, ito yung gawin natin. Assume, no? Assume deep water wave. So, if mag-assume tayo ng deep water wave, okay, assuming lang, so ito yung gagamitin natin na formula, no? To solve for L. Okay? So, let's use this formula. Assume lang tayo. So, that's 2 pi v squared is equal to GL. Okay? Now, alam natin, yung V, palitan natin yan in terms of L and the wave period. Di ba? Alam naman natin that the velocity of your wave, that's wavelength divided by period. So, substitute natin yan. Okay? And let's solve for L. Yan. Solve natin for L. Okay, then once we solve for L, ayan, ito yung makakuha natin. 63.95 meters. Okay, check muna natin, no, if sakto yung assumption natin. Compare natin si depth of still water sa L over 2. Kasi yan yung criteria natin if mag-deep water wave tayo, no? That the depth should be greater than or equal to L over 2. So, compare natin, no? So, depth is 64 meters. Okay? Oy, bakit naging 36 to? Should be, ay, typo. This is 36. I apologize. Wait lang ha. This is 36. Bakit naging 64? Ngayon ko lang na ano. Sorry, sorry. Okay? So, yan no? Na-correct ko na. So, 36 meters. Ayan. So, compare natin siya to L over 2. And actually, it's greater. No? So, pasok siya sa criteria. So, our assumption is correct. Okay? So, meaning, we will use this value for L to solve for our wave height. So, steepness natin is 0.14. L is 63.95. So, we can now solve for the wave height, H. Okay? So, H, that's 0.14 times L. Evaluating that one, the answer is 8.95 meters. That would be letter. Okay? So, letter B yung tamang sagot dito. May reference book din po ba tayo for problems like this, sir? For ports and harbors? Yes. Yes. No? At yung, ano, by, okay, eto, I think kilala niyo yung author na to. Yung book is Transportation Engineering and Ports and Harbors. I think kilala niyo kung sino tong author na to. Okay? So yan, yung Transportation Engineering, you can find that one in the internet. It's free, no? Transportation Engineering with Ports and Harbors or and Ports and Harbors. I actually have that book. Yan yung reference ko for Ports and Harbors. Okay? Yan. Yan yung reference ni examiner actually, no? And Ports and Harbors. Yan. So, grab a copy of that book, no? That's the reference. Diyan kumukuha si examiner. And the author is, well, you know this one. Okay? So, ito yung author. So, yan, no? Hanapin nyo yan, no? Sa internet. Nasa internet lang, no? Nasa internet lang. Or if you really want to see it, ito yung book na yan, no? That one. Okay? Yan. So marami dun, no? Marami. The author must not be named by. Yes, that one. Okay? So wag na natin pangalanan. I think you know who that is. But you know what? In all fairness, although maraming feedback sa book niya na there are a lot of errors, no? Honestly, may errors din naman. Kahit kaninong book, kahit sa CA reference, may error nga din eh. But when you look at the problems made by that author, it's actually good, no? Possible sa board exam, no? So that's why we also take that one as one of our references. Okay? Yes, gets a God poster. Okay, sige. Find that book, no? Find that book. Nasa internet na. It's free, no? It's free. Okay, sige. Proceed tayo. Let's have this one. So the path of Typhoon Dindo passes through Batanes Island, a certain location whose depth of water above the bottom of the sea is equal to 150 meters. So we are to determine the approximate velocity of the wave propagation in kph. Now, alam natin that velocity of the wave, di ba? That's wavelength over t. Period. No? Wavelength over t. But we can also calculate for the velocity of our wave by simply using these formulas. Ay nako. Yan. Eto, these formulas right here. Pili ka lang, no? Dito. Kasi nandito yung V eh. Diyan. Diyan yung V. O nandito yung V. The only problem is, saan yung gagamitin natin dito? Is it for deep water wave, transitional water wave, or long waves? Hindi sinabi. Hindi sinabi sa problem. Okay? Hindi sinabi. Now, if yan yung case class, assume lang, no? Assume deep water wave. Yan. Assume deep water wave. Okay? So, yan. Actually, wala kang comparison. Wala kang comparison talaga, no? Between D, no? D and L kasi hindi given yung wavelength, no? So, we're just gonna assume that this is a deep water wave. Well, if you base it naman, no? Yung depth of water, 150 meters. Napakalalim yan, no? Napakalalim, 150 meters. Medyo malalim yung 150 meters, of course, no? Medyo malalim yan, 150 meters. So, obviously, you can conclude na deep water wave ito. But if that's the case, just assume lang na deep water wave. Okay? So the depth of still water at that point is 150 meters. Okay? Assuming deep water wave. If walang lalabas sa choices, okay, use the other formula. Yan na lang, no? Yan na lang yung gagawin natin. If walang lalabas sa choices. But first, assume deep water wave. Okay? Alright. So, alam natin that for deep water wave, di ba, the criteria is D is greater than or equal to L over 2. Okay? But para makuha natin yung L, para makuha natin yung L, i-equate natin yung depth equal to L over 2. Okay? Yan. So, equating that one, L is equal to 2D, the length or the wavelength is just equal to 300 meters. Okay, so substituting it dito sa ating formula, okay, or rearranging the formula rather, kuha natin yung wave velocity but in meter per second pa po yan. Okay? Meter per second pa yan. So, we need it in kph. Alam nyo na yung conversion factor. Multiply it by 3.6. So, evaluating that one, eto yung velocity. Okay, nasa choices, may malapit. So, that's letters. Actually, lumabas to eh. November 2021. And I think, lumabas to sa module 3 ninyo. Papalabas mo na ba to? Ay, mukhang wala pa. Ay, hindi pa pala. No, hindi pa pala. Hindi ko pa pala to pinalabas sa module 3. Hindi pa pala. It's it. Okay? Sige, questions? Hmm? Hello sir, legit pa ba ito na coverage? Di ba hindi natin ma-predict kung ano talaga lalabas na topics? Yes, that's legit. Yan. That's legit. Yan talaga. Yan talaga. Hindi isa hindi ma-predict yung topics. Okay? Okay. Yung ano is hindi natin ma-predict ano yung exact problems na lalabas. Ayun. Okay? So, math kasi is very broad. Unlike HPGE and PSAD. Oh, you know where to go. But, for yeah, legit to. This has always been the coverage ever since after the pandemic. Okay? Ito na yung coverage for math talaga. Okay? Yan. But although may nakalagay dyan, wala ng algebra, wala ng trigo, wala ng geometry, you know what? Under na yan sa applied math. Okay? Under na yan sa applied math. Okay? Lalabas pa rin yan. Yung mga algebra, geometry, trigonometry. Lalabas pa rin yan. Legit yan. Okay? That's legit. So baka na ano kayo, uy, calculus, wala ng algebra, trigo. Meron pa rin. No, meron pa rin yan. Anyway, you can see the trend naman sa C reference. No? Meron pa rin lumalabas. So, na ano na lang siya, under applied math. No? Under applied mathematics. Alright, sige, next. Next. Let's have this one. Okay, ito, medyo mahaba. A tsunami, also called a seismic sea wave, tidal is a catastrophic ocean wave, usually caused by a submarine earthquake occurring less than 50 kilometers beneath the seafloor, magnitude greater than 6.5 on the Richter scale. So underwater or coastal landslide or volcanic eruptions also may cause a tsunami. So the term tidal wave is more frequently used for such a wave, but it is a misnomer, for the wave has no connection with the tides. If the depth of water at a certain point in the ocean is 1,200 meters, determine the velocity of the wave propagation in kph. Actually, irrelevant tong mga statements na to. Yan, irrelevant to. So, para bang, ano, story-story lang. No? Ganyan yung math. Sometimes, no, questions sa math, they're irrelevant statements, no, na tell lang ng story. But even without that, ito lang yung problem, okay na. No? Oh, bakit nilagay pa yan? Di ko din alam. Ayan, no? So, these statements are actually irrelevant. You can skip this one. Hanapin mo lang talaga yung actual question. Ito yung actual question na yan, no? If the depth of water at a certain point in the ocean is 1,200 meters, determine the velocity of the wave propagation in kph. Again, this is similar to the previous example, no? So, di natin alam if this is deep water, transitional, or shallow water wave. However, since tsunami, of course, tsunami is a tidal wave, no? Ang lalaki niyan, no? So, it's assumed to be a deep water wave. So, deep water wave, again, no? Pag hindi nakastay. So, assuming deep water wave, tinan niyo yung depth of still water, 1,200 meters. Malalim na yan, no? Then, okay, assume deep water wave. So, let's calculate L muna by using this criteria. D is equal to L over 2. Yan. So, calculating L, that's 2 times 1,200. Okay, ito yung wavelength natin. Okay? So, using this formula for deep water wave, 2 pi v squared is equal to GL. And, so, calculating the velocity, yung makukuha natin is in meter per second pa yan. Alright? So, converting to kph, multiplied by 3.6, and this is the answer. 220.4, the nearest one is letter B. Yan. Okay? So, a matter of rounding off lang dito. Okay? A matter of rounding off. So, yan lang. So, formula-based, no? Formula-based itong waves, no? Ports and harbors. Formula based po siya. Yan. Okay, next, let's have this one, no? So determine the wave velocity which causes a wave height of a long wave. Ito nakastate talaga, long wave. So we have to use the formula for a long wave. O nakastate talaga, no? Equal to 18 meters if it has a steepness of 1 over 9. Okay, so solution. Okay, ito yung wave height natin, no? High wave height is 18 meters. Okay, steepness. Okay, given yung steepness, 1 over 9. Okay, which is equal to this ratio, no? Ratio of this is h over L. Yan. H over L, that's equal to 1 over 9. Therefore, L natin is equal to 9 times H. Ayan. Okay? So, kaya naging ganyan. So, we can solve for the length or the wavelength, no? So, that's 9 times the wave height, and that is equal to 162 meters. Okay? So, the depth, okay? The depth is, anong sabi? Pag long wave, di ba? The depth of still water is what? Lesser than or equal to L over 25. So, para makalculate natin yung depth, i-equate lang natin siya to L over 25. Okay? So, with that being said, the depth of still water, divide lang natin to by 25. That is 6.48 meters. Now, using the formula, ano yung pinapahanap? Wave velocity. So, for a long wave, ito yung formula natin. V squared is equal to GD. Okay? So, getting the square root of that, then substituting the values. Okay, ito yung velocity natin in meter per second. Convert to kph multiplied by 3.6. This is the answer. Letter D. Okay? So, ayan, no? So, hanapin nyo lang yung book na yun, ha? Yung sa, reference natin dito. Then, you'll see a lot of practice problems right there regarding this topic. Okay, no questions? Wala. Okay. Now, how about these examples, no? So, ito. Actually, this is the last portion, no? This is the last portion of our discussion. Okay? So, we have 4 remaining examples na lang, no? For this morning. Okay, so let's have this one. So, May 2017, you can check CE reference 4 for this. Yan. CE reference 4. Hanapin nyo to. I forgot what number, but hanapin nyo lang, no? CE reference 4. Okay. So, the wavelength of the deep water wave during Typhoon Binta at the port of Iligan is 310 meters. So, the still water is located 0.95 meters below the center line of the rotation of the wave. So, if the steepness of the wave is 0.16, determine the vertical distance of the wave through from the bottom of the ocean if the depth of still water is 50 meters above the bottom of the ocean. You need to draw the figure for this one. No? And ano yung figure na i-draw mo? Ito, this figure here. Yan. You need to draw this one. Kasi nag-mention ng center line. Still water. Ayan. You need to draw this figure. Okay? Based lang sa given na statements. Okay, so let's draw the figure. Ito yung wave natin. This is the ocean bottom. Right? Then, ito yung wave crest. Of course, that's another wave crest. Ito yung ating wave through. Okay? Then, ito yung wavelength. Okay, sabi sa problem, wavelength is 300 meters. Alam natin that's the horizontal distance between one wave crest to another. Okay? Then after that, you have here the wave height. Okay, that's the distance between the wave through and the wave crest. Yan. So, ano yan? Then, ito yung center line of rotation ng ating wave. Okay? O, yan. Take h over 2 yan, no? Then, ito yung still water level natin. Yan, this is the still water level. Okay? Establish natin yan. And sabi sa problem that yung h sub o, ano yung h sub o? That's the distance of the still water from the center line. It's given. That's point. Okay? Wait lang ha. Okay. Sige, ayan, no? So, that's your H sub O, no? Still water daw is located, ito, yung still water, 0.95 meters below the center line. So, that automatic, that's your, right? Okay. Now, yung pinapahanap is what? Determine the vertical distance of the wave through. Ito, determine the vertical distance of the wave through from the ocean bottom. So, yan yung distance y na yan. Ito yung okay? So, yan yung pinapahanap for this problem, that distance y. Then, sabi sa problem, yung depth ng still water, ito, that is 50 meters above the ocean bottom. Okay? Ayan. Alright, so ito yung wavelength, 310. Steepness is 0.16. Okay, so that's h over L. So, hanapin muna natin yung wave height, h. Okay? So, using that equation, the wave height is just 0.16 of the wavelength. So, substitute natin. So, the wave height is just equal to 49.6 meters. Yan, ito yan, no? 49.6. O, ayan. Now, sa figure, di ba, look at the figure, di ba, yung D plus H sub O, ito, here, D plus H sub O, di ba, that's equal to Y, ito, Y plus H over 2. Di ba, from the figure. O, ito yung H over 2 natin eh, from the wave through towards the center line. So, that height, that H over 2 plus Y, no, from the figure, equal lang din yan, okay, towards the center line tayo, no? That's H sub O plus D. And dyan natin makukuha yung Y. Okay? O, given yung depth. O, ilan yung depth natin? Depth is 50. O, ayan, no? H sub O is 0.95. H over 2 is 49.6 over 2. So, evaluating that one, Y is equal to 26.15 meters. That's letter C. Ay, sorry. Okay? So, that's it, no? Ayan. Okay, next tayo, no? Similar example to this. Let's have this one. So, the wavelength of the deep water wave during Typhoon Binta, ay, repeating na to. Okay, change ko lang yung given. Okay, change ko lang yung given. Alright? Chinange ko lang. Sige lang, no? Okay, this is the same example lang, no? But the only difference is, okay, run through ko na lang. Chinange ko to, yan, and chinange ko to. Same lang, no? Hindi ko na malayan. Ito. Chinange ko to, chinange ko to. Okay, so diretso na lang natin to, ah. Diretso na lang, hindi ko na malayan, no? So yan, no? That's the same. That's the same problem lang. So same solution. Ito yung sagot, 16.10. Change ko lang yung given. Yung change ko is yung H sub O and yung depth. Yan. Okay? So same solution lang, no? Yung process for this problem. Okay, then let's move to the next. Okay, ito. Yan. The velocity of wave propagation produces a wavelength of 300 meters and a wave height of 25 meters. So if the depth of still water in the ocean is 80 meters, determine the elevation of the wave crest above still water level. Ito, iba na to. So you have to draw the figure. Ito yung wave natin. These are the wave crests. Ito naman yung ating wave through. Okay? Given yung wavelength, that's 300 meters. The wave height is also given, 25 meters. Okay, so ito yung center line natin. So of course, no, since given yung wave height natin, at the center line, kalahati yan ng 25. So tig to 12.5 po yan. Okay? Then ito yung still water natin. That's it. Then H sub O is not given. Okay, so we need to solve for that one. And yung pinapahanap is yung elevation ng wave crest. Ito, from the above the still water. Okay? So yan. Okay? It's actually not still water level but ocean bottom, no? Yan. Sige na lang, no? So yan yung D, no? 80 meters. Okay? That's 80 meters. So solution natin, wavelength is 300 meters. Wave height is 25 meters, no? And the depth is 80 meters. So solvein muna natin yung H sub O. Yan. Let's solve for the H sub O by using ano natin? Kalimutan ko. This formula, no? Saint Venant and Flammant theory. Yan. Okay? That formula. Alright. So ito yung formula na yan. You have H, you have the wavelength, you have the depth, and you have the hyperbolic cotangent. Okay? So input nyo lang yan in your calculator, and your H sub O is 1.755 meters. Okay? So, di ba, from the figure, okay, hindi to above still water level. Let me change that one, no? It should be above the ocean bottom. Okay? So, ayan, no? Alright. So, from the figure, okay, pinapahanap is elevation ng wave crest from the ocean bottom. Di ba? If you look at Y, di ba, that's made up of, eto, the depth of still water, plus H sub O, then from the center line, plus H over 2. Ayan. Okay? So with that being said, that's 80 plus H sub O, then plus H over 2. Your Y is equal to 94.255. That's letter B. Now, if yung pinapahanap naman, elevation nito above the still water, ayan, yung elevation nito above still water, how will you solve for this? O, di ba? It's this value here. Yan. That value right there. If yung elevation yan, above the still water lang, that's 12.5 plus H sub O. O, di ba? Yan lang. If we are referring to the previous statement, no? If above still water lang siya, so that's 12.5 plus H sub O. But since from the ocean bottom tayo, so look at the figure, it's 12.5 plus H sub O, then plus B. Ayan, no? So that's letter B. Okay, sige. Okay pa? So, walang tanong for this. Okay, let's move to the next example. Okay, next example tayo. How about this? Okay. So, the amplitude of a deep water wave is 2.4 meters. Now, pag sinabing amplitude ha, the amplitude, that is your wave height. Okay? Wave height po yan. Okay? Yan yung amplitude. So, the amplitude of a deep water wave is 2.4 meters. So, if the depth of water from the bottom up to the crest of the wave is 46.2 meters, determine the horizontal distance between the crests of the wave. Now, pag sinabing horizontal distance between the crests of the wave, ano yan? That's the wavelength. Diba? Assume daw that center of rotation of the wave is 0.3 meters above the still water. Okay? So, ito yan, no? Draw natin yung figure, given yung amplitude. Okay? Ito yung wave crest, tapos wave flow natin. So, ito yung elevation, no, ng wave crest daw above the ocean bottom. That's 46.2 meters. So, ito yung still water level natin. Okay? Ito yung center line of ng ating wave. Okay? So, the center line daw is 0.3 meters above the still water. Okay? Then, of course, 2.4 yung wave height natin. Half of each is 1.2, of course. Okay? Pinapahanap dito is the wavelength. Okay. So, ito naman na yung gagawin natin. Okay? Let's solve for D muna. The depth. Yan, no? The depth of still water. Bakit? Kasi di ba nag-mention siya no that this is a deep water wave. Okay? And ano yung criteria natin for deep water wave? Di ba the criteria is this. The depth is greater than or equal to L over 2. Yan. So yung gagawin lang natin to solve for L is simply equate D. Equate na natin yung D to L over 2. Okay? Ayan. So for our solution, solving for D, okay? By the way, H is 2.4. And from the figure, look at this. Di ba yung 46.2, yan. Di ba that's equal to D plus H of O, then plus half of H, or that's 1.2. So from that figure, kuha natin yung depth, okay? And yung depth natin of still water, okay, base the figure, evaluating that one, that will be equal to 44.7 meters. Okay? Then, based sa criteria for a deep water wave, alam natin that depth is greater than or equal to L over 2 or simply equate that one. Then, kuha na natin yung wavelength. No? L is equal to 2D. Therefore, the wavelength is just 89.4 meters. Okay? Wavelength yan. Kasi sabi, horizontal distance between crests. Ayan, no? Horizontal distance yung ating wavelength. So, final answer, that's letter B. Okay, questions? Sir, paano po yung hyperbolic cotangent? Okay. Hyperbolic cotangent. Okay. Eto lang yan. This one, hyperbolic cotangent. Okay. Watch closely. So, alam naman natin in our calculator, we don't have the inverse trigonometric functions. Wala yan, no? Wala tayong cotangent, walang sine, walang cosecant, wala din tayong wala tayong cosecant tapos secant, no? So, pag input sa calcu, ganito lang yan, no? Okay? Okay, so lagay natin, no? So, that's pi. Okay. Pi h natin is 25 squared. Okay. Over 4, then wavelength is 300. Okay, now, if you look at the hyperbolic, wala tayong hyperbolic cotangent. We have tangent, but alam natin, di ba from trigonometry, that cotangent is what? 1 over tangent. O, yan. So, pag input nyo sa calcu, 1 over hyperbolic tangent. O, yan. Di ba? Okay, erase na natin to. So, lagyan nyo ng parentheses, then fraction, 1. Kasi reciprocal ng cotangent, tangent. O, di ba? Yan. 1 over hyperbolic tangent. So, 3. Yan. So, lagay natin. So, that's 2. Then, pi. Okay. Depth is 80. Then, over length, which is 300. Wow. Ayan. Yeah, you'll get 1.755. Yan lang. No? So, i-reciprocal nyo lang. Of course. No? Reciprocal nyo lang. So, if second yan, of course, second, anong inverse ng second? 1 over cosine. If cosecant, 1 over sine. Di ba? Okay ba? Sir, yung depth is 80. Okay, dito. Okay, thank you, thank you. Edit ko lang, no? Edit ko lang. Typo lang po. Thank you, thank you. Okay. But tama naman yung sagot, 1.755, no? Okay, edit ko lang. Thank you, thank you. Right? Sige. Tama ba? Yeah. Okay. Tama naman, no? Sa calculator natin. Alright? So, yan lang ha. Hyperbolic cotangent. No? Reciprocal. No? Trigonometric reciprocals. Yan lang po. Okay? Okay, what else? Alright, sige. So, actually, yan na yung last example natin for this, no? Ito na yung last example. Okay, so we will not go any further. So, yung spiral curves, next miscellaneous na lang, ha? Yung spiral curve natin. Okay? How about yung construction methods, sir? Yung advice ko na lang for construction methods is this, no? We will insert the discussion na lang sa refresher modules ninyo. Okay? Kasi hindi siya masyadong general eh, no? So, specific problem siya. So, kumbaga, anong tawag dito? I will discuss some of the concepts in your refresher modules na lang. No, hindi natin siya gagawing separate lecture kasi napaka-broad, no? And specific problems yung pinapalabas na examiner, no? So, yun na lang yung gagawin natin, no, for the construction methods. Insert ko na lang siya during our discussion sa modules. Okay? So, yung spiral curves, need talaga siya ng separate na lecture, no? Kasi medyo malalim yung concept nun for spiral curves, no? So, need talaga siya, no? Need siya is separate. Okay? So, anything else? Wala na? Okay, di tayo umabot ng 12, no? Surprisingly. So, trajectory ko pa naman sana abot tayo ng 12. Sige lang, no? Hanggang dito lang tayo, no? Para din may ano kayo, time to breathe, no? Ayan. So, hanggang dito lang tayo, class. Okay, that's it. So, again, for next meeting, we'll have spiral curves if may miscellaneous pa. Wala na. Sige na lang. Alay na lang natin. Alay na lang natin yung spiral curves. But anyway, I'll give one, no? I'll give one. So that will be all, class. So right now, have some rest, have your lunch, then study kayo, no? Study kayo. Then sa mga FTF students, prepare for your class this afternoon. Okay? God bless on your mid-pre board, no? This Saturday and Sunday. Okay? Sir, i-upload po ba slides today? Yes, I'll upload it, no, right away. Don't you worry, no? I-upload yan, no? With regards to the slides. Okay? Yan. If ever nag-swap kami ni Sir Onde, alam niyo na, gabi ko na i-upload, no? But since, tuloy-tuloy tayo, I will upload it immediately. Okay? Okay, alright. So, that will be all, class. So, ingat kayo. Have your lunch, have a break. God bless on your mid-pre board this weekend. Okay? So, discuss tayo ng Module 3 tomorrow. Okay? And, stay put lang. Baka just in case lang, hindi kami mag-swap ni Sir Onde bukas, no? But, if ever mag-swap, ako pa rin yung mauna. Okay? So that'll be all, class. Ingat kayo. I'll see you tomorrow and of course next week for the mid-pre board discussion. That's it and goodbye.